Welcome to the live feed for ROV Sebastian, doing its 463rd dive here from the ROV Falkor, operating in the Gulf of California. This is leg 2 of expedition FK 210922. And today we are operating in an area known as the South Pescadero Basin. The ROV is going to descend to the seafloor at a depth of roughly 3,700 meters. Currently we're descending at a depth of about 1,290 meters and going down at about 25 to 30 meters per minute. My name is David Caress. I am the overall chief scientist of this expedition and co-chief scientist of leg 2. My co-chief scientist on this leg is Raquel Negrete Aranda of CESESE, the Earth Science Institute in Ensenada, Mexico. I am from the Monterey Bay Aquarium Research Institute in Moss Landing, California. And we're joined by a science party involving others from CESESE and Dr. Robert Zirenberg from the University of California, Davis. And the goal for today's dive, the first dive of leg 2 of this expedition, is to descend to a hydrothermal vent field on the seafloor in South Pescadero Basin. This is a vent field that's been named JaichMaa Jaag, and this vent field was discovered in 2018 during an expedition on ROV Falkor, involving substantially the same group of scientists that are involved with this year's expedition. The way the vent field was discovered was through the use of autonomous underwater vehicles that mapped the seafloor at a 1 meter resolution here in the South Pescadero Basin. And with that mapping, we were able to identify areas in which there are features on the seafloor that look like hydrothermal vent chimneys or edifices. And then we were able to follow up on those observations with ROV dives to the vents. A few hundred meters to the north of this vent field is a vent field that was discovered by similar means in 2015 during expedition of the Monterey Bay Aquarium Research Institute ships RV Western Flyer and RV Rachel Carson. So again, back in 2015, seafloor surveys from autonomous underwater vehicles, or AUVs, allowed us to discover the probable locations of new hydrothermal vents. And then that was followed up with ROV dives by geologists and biologists that discovered the vents directly and then investigated the geology and the biology of those features. Now, today, when we come into the JaichMaa Jaag vent field, the primary purpose of this dive is to conduct a series of heat flow measurements across and along this vent field. And so the means for making these measurements is a heat flow probe that is integrated with the ROV. So the ROV will sit down on the seafloor and then test the seafloor to be sure that it's found a place where we can insert a rod at least 60 centimeters without hitting something really hard. So we need to find a soft place. And then we will insert this probe that has a set of temperature sensors or thermistors along a length about 60 centimeters. And then we will wait a few minutes. And after a few minutes, as things have equilibrated, then the deepest thermistor will register a temperature that is likely to be higher than the shallowest thermistor, and that represents or measures a thermal gradient in the shallow subsurface. And if you know the thermal conductivity of the material, then that gradient can be used to calculate the flux of heat by conduction out of the seafloor, and or what we call the heat flow. And the system has an additional feature wherein the thermal conductivity itself that you need for that calculation can be measured independently. And the way that works is that after having measured the ambient thermal gradient, then we introduce a heat pulse into the seafloor from heating elements along the probe, and watch how that heat then decays away over time. And that measurement of the heat decaying or the temperature decaying away or decaying down after that pulse has been introduced allows one to calculate or measure the thermal conductivity. So by doing both of those sets of observations in the single station, then you have the thermal gradient and the thermal conductivity, and that allows you to know the heat flow. And doing that complete set of measurements takes about 20 minutes at each site. And so once we get started on bottom, then we will be making these measurements and moving a few tens of meters, making another measurement, moving a few tens of meters. We're going to be doing these measurements along distinct lines that correspond to the track lines run by the AUV surveys back in 2018 when we were running the AUVs off of this ship. And the reason for that is that in addition to measuring the bathymetry at a 1 meter resolution, the AUVs also collected what's called sub-bottom profile data, which is really, it's like seismic reflection. It's a sonar that puts out sound in a frequency range of 1 to 6 kilohertz that can penetrate the seafloor and provide a vertical slice of imagery of seafloor structure to depths of 40 or 50, sometimes even 70 meters. And so the reason for this is that we want to co-locate the heat flow measurements with the sub-bottom profile data, is then we can, in the sub-bottom profiles, we can identify where there are structural changes, where the different layers in the sediments in the subsurface, or what we call the stratigraphy, and where there are faults that offset those sediment layers or the stratigraphy. And then when we see variations in the heat flow along the sea floor, we can relate those to the structure in the subsurface. And so as we get going, we'll be making these measurements along the sub-bottom profiles, along those track lines, and we'll extend those measurements out 200, 300, 400 meters to the east and the west of the north-south trending line of the vents. And exactly how far out we go depends on what we observe, because what we want to do is we want to get far enough away from the vent fields that the heat flow decays away or becomes what we consider to be the background level. So the specifics of what will, how many measurements we'll make, how closely spaced they are, and how far away from the vents we go will depend on the observations as we do the calculations in more or less real time. As we come into the seafloor, before we can get started on the heat flow measurements, we need to understand the relationship between the navigation of the ROV, where the ROV is, and the map of the seafloor topography that we had from those AUV missions 3 years ago. And the reason that's needed is again because we really want to co-locate the heat flow observations with the sub-bottom profiler. Now, as I'm looking up and looking at the video, we've stopped our descent and we're observing a jelly. I do not know what the name of this jelly is, and as I look around the room, the very experienced ROV pilots are saying, I've never seen anything like this before. So perhaps there will be a biologist watching this that can come in on the chat with what it is we were just looking at, but all I can tell you is it's a jelly. But now we're continuing our descent. So in the control room here, there is a display that's for the navigation of the ROV, and the underlay of that map is an image of the bathymetry from the AUV multi-beam data that we collected 3 years ago. And the ROV's location is going to be displayed on that from today's navigation. The navigation that we have in real time for an ROV starts with a sonar called an ultra-short baseline, or USBL, in which there is a sonar head at the end of a pole that is extended down through the hull of the ship and beneath the ship, and that sonar head is used to listen for acoustic signals that come from a beacon that's attached to the top of the ROV. And the sonar is able to determine how long the sound took to get from the ROV to the ship, and also the direction that it arrived at the ship from. And so looking at the video, is that another siphonophore? But it's a very, very different one than we saw earlier, or perhaps just a smaller one. Yeah. And so you see at the top of that, you have the swimming bells, and then lower down you have the rest of the colony, and that is, of course, one of the the really amazing thing about siphonophores is that they're not single animals, but rather they're a colony of animals, and various individuals in that colony take on different forms and functions. And some of the siphonophores are immense. They're tens of meters long or more. This is just a quite small one. All right, and now we've continued our descent. So with regard to the navigation, we have this tracking from the USBL, and I'm not sure what repetition rate they generally use, but 5 seconds, 10 seconds for the USBL.
What do you have the beacon set to? Every 5 seconds right now, or 30? I think it's every 4 or 5.
Okay, so at the moment, every 4 seconds, but every few seconds, we attempt to get a fix on where the ROV is, and more often than not, it works, and the ping from the beacon on the ROV is resolved, and we get an estimate of the position of the ROV. However, that estimate's somewhat noisy, and the greater the depth, the greater the ROV, the greater the distance that the ROV is away from the ship and its USBL head, the greater the uncertainty associated with every one of those navigation estimates. So if you look at just the raw USBL hits, they bounce around, and we're going to a depth of 3,700 meters, and on a good day, the USBL tracking is still going to bounce around 10, 15, 20 meters, just from the inherent uncertainties of the range observations and the angle observations. So in real time, we don't use just the raw USBL fixes. Instead, we feed that information into what's called the Kalman filter, that's then is also looking at inertial data, at accelerations and attitude measurements that are all part of what's called an inertial navigation system. And so on the ROV, we have an INS, an inertial navigation system. The USBL fixes are combined with the data from the various sensors on the ROV, and the result is a much smoother, more self-consistent model for the navigation of the ROV over time. Now, the absolute location of that navigation is controlled largely by the USBL fixes, and then your movements in detail are largely controlled by the inertial sensors that are present on the ROV. Depending on your depth, yeah, that's right, and we've got a Doppler velocity log, or DVL sonar, that's on the ROV. And when you're close enough to the bottom, that can give you very good estimates of velocity relative to the bottom. And that very much stabilizes the estimates of navigation coming out of the Kalman filter. And so once we're on bottom, then we'll get a very self-consistent navigation. And so as we move 10 meters to the north, say, the navigation will show that very clearly and nicely. However, the absolute accuracy of that navigation is still subject to the uncertainty of the USBL fixes. And so ultimately, we really don't know exactly where we are closer than 10, 15, 20 meters or so. And the same is true for the data that we're trying to reference to, that map that was made with the AUV. It's also quite self-consistent at a level of a meter or so, but its absolute location is unknown to within, say, 20 meters or so. So when we first drop in, we're going to have to figure out where we are relative to the map and what the offset is between today's USBL and INS combined navigation and the map. And then that will allow us to orient where we do the sighting of these heat flow observations. Now we're now made it to a depth of about 1,800 meters. When we first drop in, we're hoping to come in between two very large hydrothermal vent edifices. These are structures that are 15 or meters high or so and about 50 meters across. They're constructed largely of carbonates. The reason that we have carbonates here rather than polymetallic sulfides that make up hydrothermal chimneys in hard rock basalt spreading centers like the Alarcon Rise to the southeast of here, or the East Pacific Rise further to the south. The reason that we get carbonates in this setting is because the South Pescadero Basin is heavily sedimented. And so we have volcanism that's expressed as intrusions of dikes and sills at depth in the sediments. The heat of the cooling, the heat derived from the cooling of those lava emplacements in the subsurface drives the hydrothermal circulation, so we get the very hot fluids that are buoyant and move towards the surface and then come out as hydrothermal vents. And there we have yet another siphonophore, and I think yet another species as far as I could tell.
This is the one that we saw up earlier before you went.
Oh, it is the same as we saw.
I don't think they saw it though.
Okay. So we saw one of these earlier. Again, there we're focused on the dive bell, or the swimming bells at the front, as it were, of the siphonophore. And then we're panning down along the colony, and you see the specialization of all the individuals that make up various functions, including catching food with the tentacles, and then digesting it. And you get a sense of just how long these colonies can be. You see the stinging cells hanging down, and can you give me an estimate of the size of the colony that we're looking at?
Put the lasers on right now. Devices. There's one laser right there, two on the same time. So just that little spot right there.
Okay, so you
over
see-
10 centimeters.
Okay, so if you see the two lasers there on it right now, that is 10 centimeters apart. Those are parallel lasers that are 10 centimeters apart. So wherever you see those impinging on something in front, you can get a sense of the scale. So that siphonophore, I think, was probably 4 or 5 meters long in total. I might have that wrong, but certainly if you stretched it out, I think it would be, at least 3 or 4 meters long. Okay. So we have this problem when we come in on bottom here in the not too distant future. We're now at 1870 meters and descending to 3,700 meters depth. What we're going to do is drop in onto bottom in between two of these large edifices, these carbonate edifices. I think what I failed to finish saying was that the fluids in the hydrothermal cells, in this hydrothermal circulation, the heat originates and the fluids originate in the basalts that are emplaced in depth, but then those fluids interact chemically with the sediments as they migrate upward. And as a consequence, although the fluids start out being a similar chemistry as you would have on the East Pacific Rise or the Alarcon Rise, the sulfides and many of the metallic elements wind up being removed from the fluids, and you wind up with a carbonate chemistry. So then when these fluids come out, and in this vent field they come out at about 370 degrees Celsius, what's precipitated out are not polymetallic sulfides, but rather carbonates with various other trace elements as well. But again, it's a very different sort of chemistry than what you get at what are called black smoker vents. And we won't see black smokers here. What we will be seeing are clear fluids or white cloudy fluids coming out. So we will drop in on bottom in between two of these large edifices. These two edifices are separated by about 100 meters or so. And we will use the scanning sonar, and we will use a video to figure out where we are on the map. So we will look for a couple of features that are really little mounds that I think are recognizable or should be recognizable visually and in the scanning sonar. We will go to those. We will then understand what the offset is between the USBL INS navigation that we have today and the map, and then we will do our further operations with that in mind, so that we apply that offset as we try and occupy the exact sites that we're hoping to occupy. So then we will be doing these heat flow measurements. We also have in mind to do a couple types of sampling. One of these is to do push cores, where we will use the ROV manipulator to pick up and insert into the seafloor a push core collector that will collect a short core of the seafloor sediments. And the tubes we're using are about how long?
30 centimeters.
30 centimeters is what I'm hearing. So we might get as much as 30 centimeters of sediment in one of these little cores or push cores. We're going to be taking a few of these cores for colleagues at UABC, the Universidad Atómica, I'm not saying that correctly, but Baja California and Ensenada, California, or Ensenada, Baja California North. So the colleagues at UABC are looking to understand the composition of these surficial sediments in the area of the vents, in the area of diffuse venting around the main vent edifices, and far away from the vents. And they're interested in the large scale chemistry and composition of those sediments, and in the trace elements, and including trace elements like vanadium, that the differing compositions of some of these trace elements reflect the processes that are going on at depth in the alteration of the hydrothermal fluids as they interact with the sediments. So one of the ways that people try and understand what's happening geochemically is to not just look at the largest components of the composition, but really the trace elements. So now we're seeing another jelly.
Cone jelly.
Cone?
Cone jelly, ctenophore.
Comb jelly or ctenophore. Obviously really beautiful, red and purple. So glancing over at the chat feed, there's a question that just showed up. Yes, you're correct, Nooney. Yes, a different file. I mean, ctenophores, for us geophysicists, we would still call them jellies because they're jelly-like animals. But you're right, the ctenophores are very different from medusae. And as has just been noted by our tech, bloody belly comb jelly. I don't think I've seen one of those before myself, so that was pretty cool. So we're now at a depth of 2,100 meters. So we're going to 3,700 meters, so another 1,600 meters to go. Everything is looking really good with the ROV. So we continue to go down at 25 to 30 meters per minute, except when we stop to look at the scenery.
No, I'm still going the same speed. I don't stop the winch.
What's that?
I don't stop the winch.
Oh, I see.
Always paying out at 25.
So you just catch up to it then?
Yeah, so like my delta right there is what my payout is over my depth. So 55, now I'm back to where my delta is getting tight. So if I see something cool, I can stop, go look at it, and then as my delta builds up, that's why I just take off real fast and go real fast.
Oh, great. So, J-Rod, can they hear you just fine? So, okay, so great. So I don't need to repeat that. What you were just listening to J-Rod, the lead ROV pilot on this expedition. So there was a question a little bit up in the feed about are any chance of a brine pool? I'm not sure if it's what you're referring to, but we have a very good chance on this, perhaps not this dive, but on one of these dives, of getting a close look at some of the vent structures here, in which there are flanges that build up, that are accreted and form at the vents, primarily of carbonates, and that the buoyant vent fluid pools underneath these flange structures. And then if you look at it from underneath, you'll have the very hot vent fluid pooled, and it has such a strong contrast in temperature and composition, and therefore density, between that and the ambient seawater, that the interface between the two fluid masses acts like a mirror optically. And so as you look at it within the video, you'll be looking at a mirror from below. That happens, or it's present at several places in this vent field. And I can say that even though we really, in 2018, we really only had about 2.5 dives of exploring this vent field. We haven't been to all of the edifices. We certainly haven't looked at everything. But even so, what we found was that it's got some of the lushest, densest biological communities that we've found at vent fields like this. And there are numerous flange structures which exhibit these the pooling of the fluids underneath hollows. And in particular, in 2018, there was one site that is essentially a cave that had formed, and then the fluids were pooling in the upper part of that cave, and it was just spectacular. And Z, do you remember the name? I don't remember the name for the cave.
I think it's Te Uja.
Te Uja.
I think.
There are people on shore that will correct us on that, but
And the name JaichMaa means liquid metal, coming from the reflection of that.
okay. And does anybody have any idea if Z was loud enough there to be heard, or?
You can go for it.
Okay, so the what Z just pointed out, Dr. Robert Zierenberg, who was the overall lead scientist of the 2018 expedition, and is a geochemist, specializes in hydrothermal fluids and their interactions with sediments and hard rocks. But we call him Z, and Z just reminded me that the name of the vent field, JaichMaa Ja'ag, means liquid metal. And so the vent fields and the individual vent features, both here at this vent field, discovered in 2018, and the Auka vent field a few hundred meters to the northwest that was discovered in 2015, all of the names that we've given to these derived from the language of native peoples of Baja California, and specifically the Quilwa people, I believe. Now, I don't know what we're looking at here, so someone will have to tell me.
It's a type of
It's a polychaete worm. Okay.
What type? I don't know. I've never seen this before.
Okay. Well, again, the people in the room have not seen this specific animal before. I'm sure somebody out there has, but
I'm sure Greg can tell us.
yeah, I'm sure Greg Rouse can tell us if he's watching online.
John
But-
Bayer's online. I'll tell you if he identifies it.
Oh, okay. Yeah.
Somebody said Joe Mayer.
Yeah, there are a number of worms and other sea cucumbers, other animals that have forms. Of course, cephalopods, squids, and octopi have forms that live in the midwater that are pelagic and so that was a polychaete worm.
I was looking at a sea spider before that.
Okay, and J. Rod just noted that what he was looking at before while I was talking along was a sea spider. Question: is the frame delayed because of the depth? No, it's our connection, our satellite connection to shore and onto the internet, and through YouTube, and actually there's a fairly complicated infrastructure that gets this feed out onto YouTube, and there's just intrinsically a delay. Okay, and in the chat, it stated that perhaps it was not a sea spider, but rather an isopod,
Really?
Munopsid isopod. That comes from a viewer listed as the unknown explorer Lisa.
She's normally right.
Okay, well, Lisa has credibility with the ROV crew here.
Most of them do. Got a lot of regulars on there that they spot this stuff for us pretty quick.
Well, so I was talking a bit about that cave and the flange structures and the amazing visuals of those vent features that are present at this vent field that we're descending into. The final sort of measurement, or in this case actually sampling, that we're hoping to do, and it's not clear whether we'll actually do this today or put it off to a subsequent dive, but we are planning on collecting samples of the vent fluids, and so that's an effort that is being led by Z. We are carrying on the ROV two kinds of vent fluid samplers. One's called a major sampler, and we have 3 of those. And those basically will pull in the vent fluids into a volume through a nozzle, and just store those fluids, but do not attempt to have it be sealed at pressure and be sealed such that it stores or keeps in all of the gases that are in the fluids. So the J-Rod's brought up onto the view. This is what you're seeing. What these samplers look like, and so the major samplers are on the left, and he's looking over at those. So again, we have 3 of those, and those take in a fairly large volume of water, 750 milliliters of fluids. And of course, these are constructed so they can withstand the very high temperatures. We're expecting the fluids to be at about 370 degrees Celsius. And so a lot of the components are made of titanium. And then J-Rod's now panning over to what are called the gas type samplers. And these again withstand the high pressure, but these take in a smaller volume and keep it at a smaller volume. How much?
Probably 150 mils, I think.
Probably 150 milliliters or so, and keep it under pressure and keep all the gases, therefore, in the fluids. So all the volatiles stay in that. And we want to, at every place that we collect vent fluids, we want to have one of each of those kind of samples. So we've got 3 gas tights and 3 majors, and we can therefore sample 3 vents. Do you have it set up to go underneath?
We can sample under flavors. They probably will.
Okay. So these are
Cave that way.
yeah. So one of Z's primary targets is that cave that I referred to. Another is another was marker 5, which has a flange and
It was a big chimney so it's 4 meters high that collapsed, and we sampled the base of it, and we'll see if it's regrown.
Okay. So that was the marker 5 chimney, was one that we sampled some of the actual chimney material back in 2018, and it was a quite high volume, high rate event at that time. And so we hope to look at that. So we have another one of these isopods.
No, polychaete.
You're sure that those are
That's
polychaete?
This one was a polychaete.
This one's a polychaete. Okay.
I saw before that I called sea spider, not poly.
Oh, that's right. Okay, so these are, yeah, right. Polychaete. So Z has at least those 2 sites in mind to try and get good vent fluid samples. And depending on how things go with the heat flow and what kind of rhythm we get into or don't get into in terms of doing the heat flow transects, we may or may not break off and attempt to do the fluid sampling today. But if not today, then tomorrow or the next day. With the gas tight and the major samplers, an additional difference beyond the what I already stated, which was that the majors are relatively large volume but not sealed, and the gas tights are small volume but sealed and held under pressure. The other difference is that those gas tights are not something that we can process here at sea. We don't have the equipment to extract those into equipment that we can do the analyses on, that's sealed and uses vacuums and really separates out all the gases and does all the measurements that are desired. So those gas tights are something, each one of those we take just one sample on the expedition and we ship it back to the lab to be processed on shore. The major samplers, on the other hand, we can extract the fluid sample, put it into a container, save it, and reset that sampler to be used again. So we can reuse all the major samplers that we have, but we can only take as many gas tight measurements as we have gas tights, and we have 10 of those. So that's the maximum that we can of those type of samples that we can take on this expedition. Okay, there have been a couple of questions in the feed. One is this a short dive? And the other, is this the first dive, or did they do one yesterday? This is the first dive of leg 2. We did one test dive during leg 1. Leg 1, led by Ron Spells of UABC, was aside from that one dive, was devoted to shipboard multi-beam mapping, collecting much improved modern multi-beam data across all of the basins of the southern Gulf of California. So that included the Carmen Basin, the Farallon Basin, the North Pescadero Basin, and we didn't during leg 1 cover the South Pescadero Basin where we are now, because that had been mapped with Falcor back in 2018. This will be a short dive, but the reason is that we went into the water this morning, and there was a fault. As we started to descend, there was a fault with the vehicle hydraulics. There was a problem with one of the hydraulics valves, and it was a controller, not the valve itself, but a valve controller. And so we had to recover the vehicle. The pilots replaced that faulty controller, and then we've gone back in. But it does mean that the dive necessarily is shorter than it would have been, and we will, I think, get some time on bottom, and we will be able to get things done. But it's not really a short day. It just had to work through that one issue with the ROV.
So we'll try to stay down longer. I got to talk to Ken.
Yeah. So there's a question there. What is the team most looking forward to on this dive? Well, for the heat flow team, which includes both people on the boat and people working remotely from on shore, they've been planning for a long time how to do what hopefully will be a uniquely detailed heat flow survey of a sedimented hydrothermal vent field. So I would expect that they are all very excited about finally having the opportunity to collect these data. For myself, that is really, really important, and I really think the heat flow results that we had at the Auka vent field back in 2018 were really astounding. It was just an amazing result to be able to understand the subsurface hydrology of the vent field through the combination of the heat flow profiles and the sub-bottom profiles in the bathymetry. So the hope that we can do even better than that here with the planning and the number of dives we have available is pretty exciting. That said, over the last few days, I think all of us involved with this expedition have been reviewing the dives that we did in 2018 and some of the other dives done off of the Mbari ROVs as well. And it for me, looking at those dives from 3 years ago, just reinforced my memory of just what a beautiful place this is. Many of us have worked in a variety of hydrothermal vent settings, but this place really stands out just for the density of the biology and just how visually stunning it is, from the different colors of bacterial mats to the so-called purple socks, the Xenoturbella profunda, that inhabit some of the diffuse venting areas, to the various worms and other things, and of course the tube worms. It's just really an amazing place, and so I think everybody's going to really enjoy seeing it again. And of course we've got students involved here that haven't been to sea before and haven't done this before, and I'm also looking forward to seeing how they react to this opportunity. Well, we're now at 2,770 meters depth, So less than 1,000 meters to go.
We're getting there. one. Yeah, science fiber optic.
Here you go if you want to, here's some notes if you want.
Okay.
Yeah.
All right, yeah, go ahead and pull it out and clean it through.
And zooming in and out, is that
Scroll it enough.
okay? Great.
And if you click on it and drag it.
Left click it. Yeah. Okay. Thank you.
Yep, and so it's already out. So if you want
Yep. So I'm back. We turned off the mic for a few minutes, but so
to turn up that one.
the pilots are working to
One that says science.
clean a fiber optic
That's science
fiber
fiber.
to try and improve the camera feed. And while we're doing that, we've switched the display over to the ROV navigation map. So now you are seeing a map of the seafloor, but it's the underlay for the display of the location of the ship and the ROV. And so on this display,
Yeah, just do it while you look at this and the delay. If you watch on here, it'll be too much of a delay. You gotta watch it up here.
okay. Do they see the cursor move?
They will see the cursor. They see everything on there.
Okay. So then the red dot there, I believe that is the ROV location,
No,
correct?
that's the ships.
That's the ship? Okay. Oh, and this is the ROV, yeah. So the ROV is here, the ship is here, and then what you're looking at below that is a map of the seafloor bathymetry that was generated using data from autonomous underwater vehicle missions in 2018. So what we were using were the Mbari mapping AUVs. They're a Dorado class AUV. That's a half-meter diameter, roughly 9-meter long, torpedo-shaped AUV with a single propeller at the tail end as propulsion. The steering is from the articulation of that propeller, along with a ring control surface that surrounds the propeller. So the propeller is in a duct. The duct and the propeller articulate to direct the vehicle. These AUVs run missions that are around 18 hours or 19 hours long. We run at 1.5 meters per second or 5.4 kilometers per hour, which over 18 hours yields about 80 to 90 kilometers of track line on bottom, depending how much time you spend going up or down. And then the vehicles fly at a 50-meter altitude. They use a multi-beam sonar and side scan to generate bathymetry side scan, and also they have a sub-bottom and to do the sub-bottom profiles. And so they generate bathymetry at about a 1 meter lateral resolution. And as I zoom out now, all of the bathymetry that you see here was collected using those AUVs. And this is just a subset of the surveys that we did in 2015 and 2018. And where I've got the cursor right now, that's where we're headed. That is the JaichMaa Jaag hydrothermal field. And up in this region up here, you can see small features there. That's the Auka hydrothermal vent field that we discovered in 2015. And so you see the various edifices there. And we did quite a lot of work there in 2018 because that was the vent field that we already knew about. And then in the course of that expedition, we were diving on Auka, but we were also running the AUVs. And so that's how it is that In the course of the expedition, we discovered this new vent field, and then only had time for 2 or 3 ROV dives to explore this. So now I'm going to zoom in a little bit. Let's see, I'm going to pull up on my laptop the names. The northernmost pair of edifices where the cursor is now, that one is named Mukt Mapan. This one is named, the one to the right is Te Mapan.
Little sister, big sister.
Oops, I am... Okay, and what Z noted was that was little sister and big sister is what that means between those two edifices up to the north. And then here, this one is known as Te Uja, which stands for Big Cave. And then down here, it's the southernmost of the large edifices is named Wee Kual. But every time I look at that, that's spelled W-E-E-Y and then apostrophe K-U-A-L. And every time I look at it, I see way cool. But I don't think that's how it's properly pronounced. Again, all of these names were chosen by some of our Mexican collaborators using the language of indigenous peoples of the southern Baja California Peninsula. Now, you can see that the ROV is currently right in between Wei Kual and Te Uja. And when we drop in, what we're hoping is that we'll be able to recognize these two features to the north of us and then calibrate the offset between today's ROV navigation and this map. And then the dots that you see where I'm putting the cursor now, those are along that sub-bottom line. And our intent is to collect heat flow measurements on a profile that runs along that line, not necessarily at those specific points, but along the line that's delineated by those points. Before we do that, once we've figured out where we are, we actually want to do a heat flow measurement on this little mound just here to the south. And the reason for that is a place where we took a heat flow measurement in 2018. We only took 3 or 4 measurements in this vent field.
Except that it's really right there. That's where it really is.
Okay, and Z is telling me that he believes that it really is, that measurement really was there.
Yes.
And but the reason for us to try and repeat that measurement is just to see if there's a difference in the heat flow between 2018 and today. And then, as I've said before, our intent is to try and collect a profile denser near the vent field and then getting less, more greatly spaced as we get away from the vent field along this sub-bottom profile. And again, we will go as far as we need to get to a point where the signal isn't changing. And that's with an expectation that there is high heat flow, heat conducting out of the seafloor here in the vicinity of the vent field, and as you get away from it, that will lessen to a background value.
So that's why, first thing I do
Okay.
is so that I know we can get on.
Do you want to switch back to?
One of the ones are
Yeah.
50 meters.
So we're going to switch back to the normal overlay.
Or you don't do the shoot.
Do you guys think it's better?
The pressure did something to the fiber for the situation camera. The 4K was totally fine. So I guess it's still pretty fine. So it should go, lady should be sitting out the side.
Okay, so for YouTube, should we? Which?
It's going back. It'll pop up with this in just a second.
Okay.
Just a little bit of delay.
Ah, there it is.
That's how much of a delay they got.
Yeah. Okay.
If you, yeah, you can pause that video if it's throwing you off, and then you'll still have to chat.
Oh.
So up here, that one up there, that's actually what's going out to YouTube. So if you're ever wondering what's going out to them, it's that one.
Okay. Great. Good to know. All right. Well, on the chat, I see an indication that the frame rate is fixed, much better. So that's good. Well, we are getting closer. We're at coming up on 3,200 meters, 500 meters to go. So Z,
Yes, sir.
you really think it's up there?
I know it's up there
How is it you know that?
because I've locked all the films. It's right off the edge of that mountain.
When I watched it, we pointed the ROV south.
Where that thing plots is just a little pile of tailors. And where it is a bacterial map.
Yeah, I agree.
Yeah.
It's in a bacterial map, but it was a bacterial map where, you headed south for quite a ways to get to it, and then looking, the ROV rotated around and was looking east southeast, and to the right was a small mound sticking up a meter or two.
That's a little bump.
And I thought it was the little bump that's down there.
That's a pretty good sized outcrop.
Okay.
You're
Yeah.
a rock star narrating for a long time, with just that screen. I was like, well, we just discovered another of your skills.
What? That I can't shut up? I don't
No,
shut up.
I mean it. It's like not easy just to keep talking and talking and.
Yeah, well, we've all spent so long trying to get out here that there's a lot that we've been talking about to justify all this. So,
Right.
no,
but
a lot on my mind.
well done.
But well, thank you.
Remember that upside down flange we sampled?
Yeah, that's right there.
It's
Yeah.
right there just to the north, and that fell off of that mountain.
Okay. So I think the real difference is I thought we
And
traveled.
if you take the cluster where the vent fluids are sampled, they all plot.
Right,
like
but-
there. And they're really up here on the north side of the mountain. Everything,
Okay.
including when we were exploring, the whole thing just shifts north by almost 50 meters. So it's not based on just that point; it's based on the whole dive.
Okay.
And it may have changed a
I
little bit
guess
during the dive.
for me the thing was that I was trying to calibrate. We turned south and we drove for a while, and it was a question of how far did we drive.
Okay. So here's all the exploring and vent sampling.
Uh-huh.
All that moves right up to there,
Right, I agree.
and then
You wanna, I think they asked the 3D printers we have on board.
So you're saying this cluster moves to there as well. All right.
let me. Damn it! Sorry.
Do you need? It's okay, Z.
No, it's not.
He asked a long time ago.
Do you need? Are you out of power on that, or
No,
it just blanked out? Okay.
Okay, and then here is right up there. It's
Uh-huh.
That's right at the top of the mountain on that side. So that moves there, and that moves there, and that moves this right into there.
Okay.
And it all
All
fits.
right.
This sample was taken right on the edge, the scarp right on the edge there. Is where that sample was taken.
Platform, straight across,
All right.
and then,
R5 is that upside down flange. So it's just a few meters north of right where they spent all the time. So the heat flow measurement is right there. But the right there is right there.
and then the other one is.
Okay.
Yeah, I'm pretty confident in that.
All right. So, to whatever extent you just heard that conversation, Z just shifted my perspective by approximately 15 to 20 meters on the seafloor, which basically impacts where we are going to do the repeated heat flow measurement. The discussion was about exactly where that was. And Z is comparing the prior dive navigation track with the bathymetry and showing that the offset that existed, that clearly existed, requires that the actual point that we want to go to for that measurement is about 15 meters north of where I thought it was.
And the offset does change during the dive. Those two suction samples were right up in here. That was the first thing we did when we hit. This is where the octocorals are, and so that's a little bigger shift in a little bit different direction. But it, so it does change a little bit. But everything just got.
Yeah, okay. I mean,
It
really,
all- it all holds together
it's.
very
I
nicely.
tried to figure out how far we drove when we
Yeah.
left. When we left there, when we left the cave,
Yeah.
and then we went south for what seemed like a greater distance to me. But
Yeah.
but no, what you're saying
Yeah.
makes total sense.
What we actually did is we left the cave. We were here, and we lateraled around like this, and so it looked like we were driving this way, but we were actually just lateraling like that.
Okay.
We were changing heading but moving south, and then came off, so it looked like a longer distance in a different direction than it was.
Okay. Thank you, Z.
I think that's why you brought me back. We'll see if I'm right or not.
It's a reason. There are many reasons, sir.
Often wrong, never in doubt.
Well, that's the thing about navigating. It's you really it's just you should never think you know where you are when you're on a submerged platform. You don't really know where you are. You just have an estimate, and you've got to be prepared to change your perspective at any moment because you probably are wrong. It's only a question of how much you are.
Yeah.
And the actual navigation you're getting is sometimes more of a problem than a help. It's just hard. All right, well, we are now at coming up on 3390 meters. At what point will you start getting an altitude reading?
About 70.
Okay, about 70 meters, the DVL will start seeing the bottom. Or do you have another altimeter in addition to the DVL?
We do, but this one it kicks in at around 100-ish, but it's just jumping all over the place until we get to about 70.
Okay, so about 70 meters off the bottom, we'll we'll know really where the bottom is. We think we know, but it's always good to find out for
This
real.
area that I'm at right here is a good spot for me to come down and
It is, and in particular, what we want, I think, and it's up to you guys, but I think we want to be looking north as we are, and see if we can identify those two features, and then decide what our offset is. So we don't necessarily have to sit down to accomplish that. Those things are a few meters high, 3 or 4 meters high. What do you have the range at? You've got the range set to 50 meters on the Blue View imaging multi-beam.
we'll dial that down once we get down there.
Okay, so that seems, we're about, hopefully we're on the order of 40 to 50 meters south of those two features.
Yeah, everything between those two mountains is pretty benign. There's a little hill there, but it's mostly just talus. There's no high temperature flow anywhere in between them, so it's a pretty good landing spot.
Last time down here, things could have changed.
Nó sẽ mất lòng ra. À, see? No, I don't. You do test already.
Yeah.
No, I'm not going to do that.
And well,
I know. I was going to take a picture. Okay.
There are riftia on in
the
this
rare
area.
riftia, yeah,
Rare.
rare. There'd be one or two at a time.
And
And
then
to see thousands of oasis.
Oasis. Okay, so in the chat there was a comment that you'd like to see some riftia, which are the really large tube worms. What we observed here before in our, again, very limited exploration was that there are riftia present. They're relatively rare, so we would see them not in huge beds of the riftia tube worms, but individuals here and there. And the larger populations of tube worms here that we found before were the smaller Oasisia. So my expectation would be that hopefully you will see some riftia, but probably not so much. Probably a lot more of the smaller tube worms.
How deep is the seafloor? 3.
I'm sorry.
That's a seafloor.
I'm sorry.
The depth of the seafloor.
Where we're landing?
Yeah.
I don't remember. It's the same as the target depth you had there.
Okay.
So that depth is right. It's just that the location relative to the map is wrong. So it's 37 something, whatever that. Yeah. Yeah. So that's a true depth.
3684.
3684. Yeah.
Very close right now.
Yeah.
Okay.
So that's a good depth.
Okay.
Let's start on my schedule.
What's that?
Let's start.
Okay. I'll let you know when it starts dipping. See, what's the ambient pressure here right now? 5,200 PSI. about to say Cape Present.
Oh, in the chat there was a question of the maximum depth rating of the ROV, which was promptly answered correctly by several people at 4,500 meters.
Let's talk about it on the overlay. Let's talk about
You see right there? See?
Yeah, look at the profiles.
Oh, the profile. Oh.
Just in case we see a hydrothermal flow up in that lavametry will go up and the oxygen will go down because we rarely have seen blooms coming down here.
Gotcha.
But
We'd see the bubbles in the blue view if it was within 50 meters of us.
the neutrally buoyant was not yet,
I got
the neutrally buoyant. But you go through the top of that, you get a little deflection. We saw that really clearly at Aldercon. I don't remember ever seeing it clearly here.
Okay. What were you looking at the oxygen? Or?
Oxygen and nephelometry.
Okay. And
You
where
don't see
are
that
those
much.
displayed?
Well, we don't see a profile of
Yeah,
the
not
display.
a profile, but I can get you right here. So O2, which is going to be 113 micromoles.
Yeah.
Okay.
Without seeing a profile, it'd be really subtle. And, it's something we can look at after the
Yeah. Okay.
I don't really expect it, but I always like to look.
All right. Well, we are
Jimbo had a script for that. I don't know.
3,560 meters. So we are less than 200 meters, probably about 150 meters
I'm
above
about
the
100
bottom.
off bottom right now.
About 100 off bottom right now.
Yep.
Cool. All right, and oh, I see the altimeter there. Okay. Yeah, so the sonar is seeing the bottom.
So now on YouTube, they also now have an altimeter.
Okay.
As well. So as soon as we get it, they get it as well.
Yeah, and so on YouTube you can see the altitude reading there in the upper right, coming in at 60 meters or so. So in here, where I'm looking at the blue view imaging sonar, imaging multi-beam that points forward and a little bit down, and be very interested to see when we start to see the seafloor in that scan, which is going to be the initial tool we try and use to locate ourselves. Starting to see a little bit of structure there in the imaging sonar. We're pointed due north, and that features 26. Yeah, it's about 30 meters out.
two bumps there. No, that's the main chimney, or the main top of the structure.
Yeah, I think we're seeing the top.
Yep, I agree.
Oh, yeah, definitely. You think you're seeing the top of the further one?
Yes.
Okay, so I need to back up a little bit.
Yeah, you're seeing the shadow from the very top there. That looks just right.
All right, I got a view on the bottom. Here's one off to the right.
Yeah, we may want to go. south
And
a
there
little bit.
now you are seeing the seafloor of the South Pescadero Basin. JaichMaa Jaag hydrothermal vent field, and we've got a little
So there's your two rocks right there.
there's a rock. This is a large chunk of carbonate that fell off of the larger edifice that's north of us. So, moment we are facing to the
I'm gonna do a white balance real quick,
east.
just so you know.
Okay.
I'd say we're plotting pretty close to where we are, maybe just a little bit, 10 meters or less south of where we are. And if we just go to the east, we're going to find our maps, I think. We're a little close to the boundary.
Okay, so
Yes,
We're-
I'd say we're 10 meters north of where we're plotting. That's a guess right now, but
are on the navigation map, are those squares 5 meters or 10 meters?
Currently set at 10 meters.
10 meters.
The angles
Okay.
as we zoom around.
So if we rotate to the north, then we should
we should be able to see those.
see the twin rocks in the scanning sonar.
That should just be one full rock right there, right? Is that what you're saying?
Yeah, that's a piece of tail. Those two mounds are bigger than that. That's right.
Yeah, because they're more like 10 meters across and 2 or 3 meters high.
There's another one
See, it
right
looks
there.
like we're getting two shadows, I think, right there.
So that's the second one. Is what y'all are saying?
Huh.
So these are the two rocks right here, right?
Could be there.
So in that case, we're
We're almost 20 meters further north.
Yeah.
then we are plotting.
And
Yeah.
if we just lateral over to the east, we should see.
Can we get on top of this one to see exactly how far off you are?
Yeah, let's do that. So we're going to maneuver to be on top of this talus pile that we think we've identified in the map, and
I think
measure
that's the
our
top
of the one to the
easternmost one.
eastern. Okay.
I believe that's right. Yeah, that looks good.
Okay. So
There's the base of the mound with see the fallen slabs of flanges.
okay. So
Me right at the top of it.
so the way that the ROV is plotted on the nav plot, the navigation reference is in the center of that icon,
Correct.
but the beacon is where on the vehicle?
It is right in the front.
So and the icon is not sized to its, yeah, okay. So we're really looking center to
If I
center.
zoom in, it gets a little
Yeah.
more realistic, of course.
Yeah, well, it's not important. It was only important that I understand what's getting plotted. Okay, so
So I
can
think we
you
need to go
drag
2
a
meters.
can you drag a range and bearing from the reference point of the icon, the center of the icon to the center of the mound, and give us that value?
32 meters at 336.
Okay, but we're not on top of it anymore, Dave.
Yeah.
Oh, you are still on top? Thank you, sorry.
32.
I just floated up a little bit. Though.
Okay.
Okay, offset is 32 meters, and the bearing was
336.
336. Okay. All right. So then,
I think we want to go just about 120 by 10 meters. And I think we'll be right on the north edge of that bacterial map.
okay. And that's eyeballing it
That's
on.
eyeballing it, yeah. Based on that little topographic bump and
Yeah. Okay. I think we both have a sense of what the that bacterial mat looked like from the prior.
and if we see that upside down flange, it'll be very recognizable.
Okay. So.
Just trying to get a better white balance on last one.
Okay, so right now the pilots are doing white balance on the cameras, the video cameras, trying to make sure that we get good imagery. It's actually really challenging in terms of the video, because we have these carbonates that you see right in front of us that are so white. And then we also have all the bacterial mats that range from fluffy white to shiny white to blue, the other colors, and the dynamic range that's required to image those accurately while also imaging the many other things that come into view that are much darker. It's just challenging to try and get the cameras set so that they do justice to what we're trying to show and capture on video. Okay, so from where we just were, we wanted to move, you said about 120 and how far?
10, 15 meters.
Okay.
So
10, move 10 meters at a bearing of 120 from the top of the mound.
what about the Niskin that you were talking about when they take the
Oh yeah, before we muddy things up, could we fire this? Thank you for reminding me.
Connected to do it in this position right
Yeah, is it okay to do it here?
Yes, no, this is fine. This is fine.
Okay.
No problems.
All right, so what we're talking about there is we have water samplers, large volume water samplers. They do a couple of liters each, that are called Niskin bottles. And the Niskin bottles are sort of a general purpose kind of equipment that's used to do water sampling in a variety of ways, in a variety of contexts. The reason Z wants to get some water in a Niskin is basically to have ambient water from this area, from near bottom in this area, so that he can use that to wash out, to clean, and when the major water samplers, when he's preparing those for sampling on future dives. So that the point of that is to avoid any chemical contamination by having something inside the water sampler other than the substantially different from the normal water that's in the area we're trying to
We're gonna
work.
fire all of them. You're not going to need any later, right?
No.
Okay, so we can just fire them all.
Yeah.
Yeah.
So Z just needs a couple of liters of water for preparing the samples for the next few days. But not preparing the samples, preparing the samplers for the next few days. The pilot is using the manipulator to trip the Niskin bottles, and they're actually going ahead and tripping all 4 that the vehicle carries. And we probably don't need all that much water, but if nothing else, it lets them know whether or not those Niskin bottles are functioning properly. So we'll go ahead and exercise all of them from that that perspective. Okay, so what we think we figured out, and we have a moderate level of confidence in this, is that the offset in navigation between the real-time ROV navigation and the map that we have from the AUVs from 3 years ago is about 32 meters. 32 meters and a bearing of 338. 336 rather. What that means is that the location of the vehicle plots to the southwest of where we are on the map. And so in all of the movements that we're going to make from here on, we're going to take that offset into account. We do have to be careful. We probably won't have another opportunity to check this value as closely unless we come back to features that are big enough that we can see them in the map. But in fact, that offset can change over the course of the dive. And that's because the INS, even though it's stabilized by the DVL estimates of speed, of velocity over bottom, and by the USBL tracking, even so, the INS will drift. That inertial navigation will drift. And so the actual offset between the two frames of reference is going to change. We just hope it won't change too much too fast.
Would you change your mind to?
Yeah. 100.
100?
Yeah.
Okay, and then 10 meters.
And then we just want to drift to the south.
And then right click and
Yeah, I recognize those flat flanges.
right click right there. Add a marker.
So right now, Z is navigating us. He's got a good idea of this terrain because he very carefully reviewed the prior dive video. And trying to get us to pretty close to the same spot that we took that heat flow measurement 3 years ago.
Go heading you want me at?
Yeah, for living coordinates, we'll make it easier.
What's that?
If we're looking the direction.
No,
No, I want to head the same, heading the same way we're going.
okay, so
Yeah, go ahead and turn. I want to see in front of us. Sorry for that.
Currently I'm at 367, but I'm also about 10 off. So
Yeah,
I'm working my way down.
our bottom depth was 36 seconds
Go through the different depths.
at the turn.
Different depths. We have 3 different depth sensors on board. It's showing 3657. Go to CTD.
3669.
Yeah, that might be. What's the closest one to you? Or do you want me to get on bottom first? Check that out.
Oh my goodness.
Yeah, let's go ahead and drop back down.
I need that map.
High pressure valve every single day.
Okay, we're coming back down onto bottom.
Tail fin is actually already on bottom. What's a downhill slope right here? Is that what you were
Yeah, let's
expecting?
follow the slope a little bit further.
Okay, so just go a little bit away from that?
Yeah,
Okay.
and look for clams. The clams are going to get denser as we get closer to where we want to go. There's a few clam shells there. And we're looking for very bright white bacterial mat that still exists.
Some that material.
So, so Z, are we not about the same latitude as we were when we were on top of the rock?
We're a little further south.
We are?
Yeah.
So I got this right here. Keep going forward.
Yeah, turn a little south.
Turn a little south.
Yeah.
A little bit more. Or
Yeah.
there's a line right below me like a fraction.
No, those are clam tracks.
You're gonna follow the clamps and tracks.
Yeah, follow that clam.
Like that, or it's clams.
Hard to tell whether the clam was coming or going.
That bird got it. It's stripes on it.
Yeah, we got some smart clams.
So when we're talking about the clams here, these are chemosynthetic clams that live off of
Too far south.
bacteria that live in their gut that in turn lives off of the chemistry between the things like sulfates that are present in the sediments and the chemical gradient between that and the ambient seawater. So the clams typically they aren't going to live where it's really hot, but they live in the vicinity of vent sites where it's merely warm and where the chemistry allows the chemosynthesis to occur. So we are moving, trying to find this place where we took a heat flow measurement before. We're starting to see some things in the distance that look pretty promising to me on the right. That looked to me like that's not so much a bacterial mat as it is a pile of clams, so it's not the same thing.
Yeah, okay, we're right on the edge of the mountain now, so we gotta go just a little bit south again. So maybe go south a little bit west of where we went the first time. Yeah.
More significantly so, I got not significant, but I'm from 10 meters south of that point that we started at.
Yeah, this is the tail that's right at the edge of the mountain, so we need to go 10 meters south.
Sí, como un mini lavín. A lo mejor es el propio ROV.
Yeah, follow those plans.
So we're coming up on a rather significant bed of chemosynthetic clams, and we think we're getting close to where we want to be. Uh,
A little bit of a ledge off there.
Yeah. Yeah, follow that notes right there.
We're at 3674.
Yeah, we're just about right down.
Keep following the plans.
Yeah, we just sort of circle around in this area. We're about the right distance away, so it's just a matter of going east or west, I think. I'm not sure it's west right now. We're right in the right area.
so we think we're close, but we're looking for a particular patch of bacterial mat where we took this measurement previously.
Also look for subtracts. Because we spent a lot of time at that place.
Definitely.
So it's the same thing as you saw
Yeah,
before.
I just came back a little bit, but finally
Yeah.
good.
Yeah, just sort of go along those trends where they are.
Going a little southeast. I got some rocks coming up in Blueview off to my 50 meters.
Okay, we're starting to see that other bump, the one that's right there. That's what we're starting to see. So we want to go back north. I think maybe we're too far to the
I
east.
You think we're too far to the east?
I think. I think we want to be just a little more west.
Bacterial mat right behind me.
Oh,
yeah,
On the mound, yeah, there's some.
yeah, there's one on the mountain.
Okay, so don't go to that though, right?
Well, can we look at that one?
Yeah,
Yeah, that was the launch target. The launch target is the best location.
the launch longitude and latitude was the longitude and latitude in ROV navigation of the place that we want to be.
perfect, yeah. So here's some bacteria on that point.
That is, so here we're seeing some of the bacterial mat.
The way we were set up in our sampling is we were headed 055 and sampling the map. This may be the one.
I think one of these is definitely the one.
Up here, there's several patches of mat out
Yeah, I don't know if 3 years is enough time to erase the the scar where we sat down previously,
Yeah.
but
Could easily be.
It's good, yeah.
pretty active area.
Is this edifice the one that look like liquid metal? This big one?
To the north of us.
Right.
So the one that's up there.
Right.
Yeah.
We gotta go back north.
Fine fish.
But sort of follow along
Yeah.
the trend of those maps.
I'm just going to turn over on Chris real quick, let him know how bad it is.
So wait, Z, you don't think this is it?
So,
I think this is the mats on the big mountain. The central big thing in between.
these are actually
Oh,
Okay, you can bring it out.
okay.
They're sort of mats
trying
all of the north.
Yes, I know. And you still think?
I think, yeah.
I
Where we want to go is where the curve
Right there, yeah.
over here.
was.
I just came over. So
I think where we are is where it's about the cursor is right now. It's about where we are.
already taken the Niskins. So
Well, it's actually halfway in between
that's how
the cursor and where the vehicle is showing is where we are right now.
Yeah, okay. On that, yeah.
Yeah.
We're looking at the maps. on top of that
Which
little
is,
bump.
so that's where I thought we did the sample before.
Yeah.
You don't think we didn't we cross
It's
the
just a
area
little-
you're pointing to, or
Well,
and there wasn't much there?
we didn't see it. Yeah. Although,
bacterial
I think we've got the offset set based on, so if we don't need to redo that heat flow, I think we can start line, because I think the offset is pretty well done. So I don't want to spend too long looking for the map.
No,
just to
I don't
redo
want to. What I'm wondering is, shouldn't we just go ahead and sit down in this mat and take a measurement
Can we switch
Yeah.
on the hydro probe, please?
and
Turn the heat flow probe.
Yeah, heat flow provider. Sorry.
It's on.
Is it on?
so what I would suggest is let's just go ahead and go over by one of those mats. Go ahead and do a measurement. It may or may not. I think it's closer to the right place than you do, but it may or may not be right. But we'll get a measurement and then we'll move on.
That's good.
Alright, so back up to the north.
And if we're gonna start the line, kind of where the small green dot is,
Yeah.
then we got a good chance of crossing the other thing and seeing that.
Yes.
without
Yeah.
flying
Yeah.
like that.
We can go ahead. So yes, what I would like would be to go back to where we very recently were, where there were bacterial mats. So, which I think is to the north of where we are right now. And we'll go ahead and set down and we'll go through doing a heat flow measurement. It may or may not be exactly the right place to repeat the prior measurement, but let's go ahead and make sure that the system is working. Get that measurement, then we will transit north, which will take us across where Z thinks we're looking for, and if we see it, we'll stop and do it again. And if not, we'll go ahead and get back up to the north to start doing the profile. Is that okay,
Yeah, sounds
you
good.
guys? Okay.
Sounds good. But we definitely, because when we're in the map, we definitely run a probe before we put the heat flow probe in. to make
Yeah,
sure.
yeah, no,
Yeah.
so an aspect of what's about to commence here is we'll set the vehicle down in what we think is a good place to probe 60 centimeters into the seafloor without breaking anything. And the pilots are gonna use their manipulator to grab a rod that they have, just a loose rod, and then that's about the right length. And they're going to use that to poke into the seafloor to be sure we're actually sitting in some place that's soft enough to do this with, because the real probe it's not exactly delicate, but it's put into the bottom with such force that if it hits a rock, it will bend the titanium rod, and that will. It doesn't take very much to start to break wires and basically break the heat flow probe, break some of the thermistors or the wires associated with them. And so we'll probe the seafloor first, and then we'll hydraulically insert the heat flow probe itself into the seafloor. It is mounted on the side of the ROV, on the starboard side, and is driven into the seafloor perfectly vertically using a hydraulic ram. And the actual process of driving it into the seafloor, we carefully do that slowly. Again, because we're worried that if we hit something hard, we'll break it. The ram can operate pretty fast, but we want to be very careful about these operations. So we're maneuvering back to the bacterial mats that we saw before, and we'll try and do this first measurement. So I feel like we're a little north, we've gone a little north of where those mats were. Am I wrong?
I'm looking at his track from earlier, and I'm just south of that still. I feel good where the white lines are zigzagging all over.
I thought that was what we did before we saw the mats. I thought,
Southeast. Southeast, yeah.
yeah, it's that jog.
Right in here. Right in here.
This little jog right here.
Yeah.
Okay.
Yeah.
That was.
Sorry about that. I wasn't. Was looking at the other screen. So you all can get a sense of the difficulty that we have, even when we've got a great map and we've got great navigation and we got a large number of pretty smart people in the room, but it's still really hard to figure out how to get where you want to go in this particular context. Oh,
Down first. And
Yeah, we're too shallow for that.
sitting right for the south.
I would go a little bit further south.
All right.
Almost getting up their track on here. So this way there.
Yeah, maybe.
It wasn't really up here, was it? No, I don't think so. I got to kind of remember where it was exactly.
Oh, when I found the back there,
yeah. Sorry, I should have had us drop a mark point at when we were looking at those.
On video?
you should start seeing now. Harbor.
Huh.
More starboard. flue gas are coming from north this direction right here. So.
Well, to answer the question in the chat, which is essentially what are they looking for now, we're looking to get back to where we were a few minutes ago in order to do the first heat flow measurement. And we're backtracking along our track because we and there we are.
Where exactly would you put this down, sir?
Okay, so now since we don't know exactly where it was that we were before, this may or may not really even be that spot. Z doesn't think it is. So we'd like to take a measurement here, but in a safe spot.
Away from the outcrop.
All right, so that means not the carbonate outcrop, and we definitely want to be sure that. So in the foreground, I can see rocks. Need to find a spot where we can.
Just going over here.
Yeah, that's what I was going
Yeah.
to say.
Yeah, so we're gonna maneuver over to the right of the bacterial mats as seen on the screen. We're facing southwards. So we'll, I do not care about the heading. I don't know. Do we have any reason to care about the heading?
No, I
Okay.
just knew the heading of the old places.
You don't think that that might be it? He's trying to prepare himself to say no way, that's not it.
Yeah, that might be it, but
I don't see any
I
marks
don't
of
see
our
any
being on the
subtracts,
bottom.
yeah.
Yeah. I don't know. I mean, it also seems like
Yeah.
these areas are active enough that
I
the
don't
bottom
remember.
gets
I
reset.
don't remember this many carbonate blocks around,
Yeah, okay.
which is why I think we're further south.
Yeah,
on the map.
okay.
And also, it's dropping off too much there. So,
All right.
and this is a fine place, but
Yeah.
Yeah.
Okay, so let's take a measurement here if we safely can, and see if everything is working.
yeah.
Because
And then
we've got a crowd of people in here that want to know that it's working. Want to demonstrate that.
once they are
So
set
let's
up,
not wait any longer.
yeah, once they are set up and doing the measurement, you can then zoom in and look at critters in the.
That's true.
With the camera, but wait till they're ready for it.
Although it probably should be somebody that has greater facility with a camera than I do. I can try.
Yeah, does that help at all? I put it down. Well, some little rockies came up right there.
This is
So we want the pilots to land in a place where the bottom is soft enough that we can safely penetrate the 60 centimeters, and they're trying to accommodate that, but it's there's a lot of rocks around here, so we're going to be really careful. Don't want to break it on the first try. Should note that the heat flow probes that we are using don't belong to either the Sesese heat flow group or Mbari or SOI. They're borrowed from Professor Andy Fisher of the University of California, Santa Cruz. And
as far as we know, he's not watching, so we can go ahead and bet.
When you're having. That's right.
All right, so the pilots now are going to grab that loose rod that I referenced and try and convince themselves either that they got to move or that it's safe to go ahead and use the probe. Oh, you won't be able to see it, but in the control room there is a camera that is oriented to look at the probe and where it goes into the seafloor. And we'll be watching that.
Yeah, it should be the other there.
There's a sea cucumber flying by. Unless somebody wants to correct me on what that animal is. Okay.
No, that's a xenothrobella? No.
No, I think it's a sea cucumber.
Oh,
And
that's beautiful.
echinoderm.
Saying hi. That's beautiful.
Yeah, I have to say those are actually one of my favorite animals.
Yeah.
They're just so over the top weird.
That's a new category, Dave.
Yeah, I'm no biologist.
So you're thinking if we put it somewhere here, then we'll bump forward and then drop the probe?
My understanding previously was that you would reach behind and probe where it's going to go in.
No,
We're with ROV
probe and then.
So you want to probe and then,
So we can
okay,
probe down that way.
That's,
all right, that's fine. So you can see the pilots are carefully probing to see if that would be a good spot to use the heat flow probe. If it is,
Looks good.
I'd say it's pretty good spot,
yeah.
so it's agreed that it's a good spot. So then after they pull the rod out and stow it, then they'll move forward and with the vehicle oriented so that spot more or less is where the probe goes in. Oh, you're going to leave it there and
No,
then.
I was going to regrip it here to give us the kind of.
Oh, okay.
There, that way you have a target. And it'll be hard to see. It'll be all
Bill was a.
But as long as you think you can leapfrog straight forward,
I can see it here. I'll be able to see it there and just get camera hopefully.
so I'll try.
Is the video good enough that you can recognize the hole that it went into?
You know, leap,
Yeah,
leap, leap,
yeah.
against it.
Well, I think we have the quote of the day off the chat stream here. A comment from Deza Tribe that the ocean is now vaccinated.
I thought you were going to say this one.
maybe a few centimeters away would be good, because you just disturb the sediment and then.
Alright, can't see it anymore.
Back on?
Alright, so I'll come ahead a little. Oh, I don't know if it really wants to fly by. Alright, that's about right there. Yeah. I'm on the ground already.
Okay, so we've located ourselves next to where we did the test probe, and now we are about to insert the heat flow probe.
Okay, so 60 centimeters, you said?
Yes, but they want
No,
to go pretty
no.
slowly.
Yeah, so the thing is, I want to take a minute or so on and water measurement, and then I give you the comment, then you insert the probe slowly, and then
Yeah.
focus out. And
That will help the thermistors stabilize to the
Okay.
water temperature, and then
you get a stable measurement, and then
Yeah. So yeah, Florian is directing the operation here. So what you just said was that after you turn it on and start, you wait a minute.
we wait a minute to measure the water.
Until
No,
the
they seem like they were both going at a
Okay.
consistent.
slow pace. If you thought,
Okay, yeah.
Okay,
I did it like every.
ready for insert.
Okay, you want to go all the way down or just go a little bit, pause?
No, just slowly down.
Just slowly, but all the way.
down.
Okay.
Okay. We're getting these events marked.
Sure.
Everybody's
Yes.
doing that.
Yeah, Karina's doing that.
Insert it.
And just keep an eye on your roll, Adam.
Yeah.
If you see that start going, tell them to stop.
Okay, so we're inserting the heat flow probe now.
Okay, nice, nice.
After the measurement was started, we waited about a minute, so we have a good reading of what the thermistors are referencing in the ambient water. And then it's being inserted slowly. And once it's all the way in, then we will wait 7 minutes, I think,
Yes.
for the temperature of the thermistors along the probe to equilibrate to the sediment that they've been inserted into.
One is already in.
Go. It's good. Insert.
Yep. So we're putting the probe in quite slowly, and as we watch the display, we have the temperature readings on each of them. And one has gone up. I can't read the numbers.
Well, it was around 2 and it's already 4.5 at with rising. Around
So
the degrees. Centigrade.
4.5 degrees.
Yeah.
Okay.
We're a little bit faster.
We have
maybe.
second one already registered.
Yeah, go a little bit faster.
So as the first
Because we have
thermistor
we
went
have
in,
a
it started to
time
jump
frame
up.
when the heat
It
pulse goes
continues
off.
to ramp up.
So
Now
I
it's
need to.
at 5 degrees C.
I can't go a whole lot further down.
Ambient seawater
Okay, thanks.
is about 1.9 degrees C here. So
Ahí está, la pusieron acá.
Okay, that looks good.
That's perfect.
So next time a little bit faster. Okay. Thanks.
so far it looks like the probe system
Yeah,
is
fast
working
enough.
very well.
Yeah, a little bit faster. So because I have a time frame of about 7 minutes, so the signal can be carried, and then if it's too slow, then I miss the time frame. But I mean, we all just
We should, you should finish this measurement and maybe and then switch for a second measurement so I can narrate something in Spanish.
Yeah, that would be great.
Yeah.
Yeah.
So we want to play with the camera.
So insert.
What's that?
We could zoom the camera and play around.
He wants to play with the
You know what? I think you should share what you want to look at, because I just know you are so good with the camera.
Can I take the camera?
You can do
Zoom
whatever
in?
you like, sir.
I had it right there.
So you're now listening to Dr. Z.
Hello, all you Falconophiles. Have you been missing your dives? It's been a long time, hasn't it? We're happy to be back here. I hope you're happy to be with us. I'm going to zoom in here on this bacterial mat. We'll just look at who's here. Now, remember, I'm a geochemist, and so everything I say must be taken with a grain of salt. But there's a nice clam, one of the chemosynthetic clams, and the pink scale worms on either side are also chemosynthetic. And you see the fibrous bacterial mat, what we often call Beggiatoa. Ooh, got the clam excited. And then I'm going to pan up a little here. I have to try and remember how to use the camera here. And we'll look at where the shimmering water is coming out. And there's some nice focused hydrothermal flow. We're not going to take the time to measure this because this isn't a good sampling spot, but that's probably well over 100 degrees, probably at least 150. And you can see that there's a tube worm tube. That's one of the Oasisia tube worms at the top of the screen. Sorry, I'm trying to remember how things work here. The reddish things are anemones. There's also a nice little gastropod I'm going to try and put right in the center of the screen here. And I know at least one of our biologists from the next leg is watching, so they can say what we're seeing. So there's a gastropod right in the center. Yeah, let's see what else we can find here. Now we see two different types of white anemones. And if I'm not mistaken, these are the anemones that our colleague Shauna Gaffaretti, who will be on the next cruise, has determined are actually have chemosynthetic symbionts on. I believe these are the ones. So we're seeing a lot of the animals that we've seen here before. And the little pink fish that looks kind of eel-like, that's a zooarcid. They tend to hang out in the vents. There's a lot of them around here. We passed a whole school of them laying on the seafloor. So this is pretty typical of the bacterial mats and the low temperature venting areas that we've seen. Now you see several more clams with their pink siphons sticking out, so we know those are live clams, and then some dead clams next to them.
Let's, well, okay, we can,
So we noticed one of the
And again, that is a scale worm, two different scale worms, a pink one in the clamshell and a more purple one. And some more gastropods in the distance. Very interesting pink color to the mats here. Our colleague and the co-chief of the leg 3 coming up might want to welcome back to this spot. Some very nice pink bacterial mat.
Adam, how much further could we go in right now?
Just hold it there for 6 I can go till like 5
right now, don't move it.
Yeah, 5C. No, I'm not telling them to move it, but 5C might actually be enough to get that other thermistor in. Right? 5C might be enough. If we went down 5 more C, might be enough.
We can try next time.
Yeah. Okay.
well, when you're done, before we pull out, let's see.
Okay.
Okay. And then if that's the case, then we'll talk about
Yeah.
the adjustment aspect of it, how long that's going to take. Okay. So, y'all hear that?
When he's done, before we remove it, go down and see if we can get other.
Go down as far as
Well, we can punch that thing right into the ground if that's not a problem.
That's not a problem.
Yeah, so on the actual bracket, the bracket can actually go into the ground.
Well, what we observe here is that the highest thermistor is not in the subsurface right now.
Yeah.
In that
So-
camera view.
Yeah,
You
when
see
we
that
built the
bracket?
bracket, we tried to give you as much as we could, but we couldn't have it sticking this much above the ROV. We couldn't have it hanging lower because
So,
we'll clip it as we go.
See this
so
bracket
that
that
was
it's
the best we
attached
could
to?
do. But where J-Rod's
If that
pointing
goes
there,
into the mud
yeah, like you
with
said,
the
that goes
thermistor,
into the ground.
is that okay?
If you're
Yeah,
okay
for
with
the
that,
next
but
one, yeah,
just
we
stick
can
it
definitely
Oh, you're okay with that?
down,
She says it's fine.
Yeah.
Okay, so we can still go down. Do you want us to go down now?
No.
No,
No, 'cause
now
we're
it's-
in the midst
middle
of this
We're
measurement.
at the middle of
But,
measurement, but for the next one.
we want to, before
Before
we leave, we want to see if we can get it in and register, and sort out how far down really you need to go.
Okay.
So that means,
Barely.
yeah, no, all of them, just for the, before, see like all of them, down 20 degrees before and then, well, and this high continues the same temperature, so.
So you think that's only 160 degrees?
Could be hotter. Yeah. Not clear how hot that is. It's well over 100, but it's probably under 200. Yeah. I am notoriously bad at picking vent temperatures.
So
Okay.
what do you call the organisms that live off the chemical?
So the organisms that live off chemical energy are called chemosynthetic. Yeah, but most of them have bacteria that are chemosynthetic. In fact, all of them have bacteria that are chemosynthetic. So the larger animals, like us, or even the anemones or the tube worms, don't have the ability to do chemosynthesis. But they've developed symbionts with bacteria in them that do that. So it's a symbiotic relationship with bacteria that allows them to use the energy. So you might think of them as farming the bacteria inside of them as a way of getting the chemical energy out of this. And on the next leg, when the biologists are around, we'll hear a lot more about this. But here is a creature of great interest to one of our colleagues coming up. That is the famous pink sock creature, Xenoturbella profunda. And
Greg, are you watching?
If Greg were aboard, anytime I wanted Greg to come in, I'd just put the camera on one of these and he'd show up in the control room. There's a man. We'll see if that happens here, but he's got a bit of a swim to get to us.
So what's so special about a xenoturbella, Z?
I am going to let people wait until Greg, who knows things, can tell them things that are true, because I will tell you one thing. Greg is one of the world's experts on this, and he doesn't understand these creatures very well either, because they are very mysterious. He is making a lot of progress, especially doing genomics, trying to figure out what they are and how they live. But I think Greg would agree that even he doesn't know too much about them.
People is getting creative. They think it's a pink sock or a churro.
Yes. Well, they're typically called the pink sock creature. Even what they eat is not known. They seem to eat clams because often when they've tried to sequence them, they find clam genomes in them, even though they're not in the clam family. But a bigger question is what eats them. I have my theory, but we'll hold that for later. One thing I haven't seen yet are the para-alvinellids or palm worms. They typically live in the hot areas like the edges of the shimmering water, and I haven't seen any of those yet, but we'll keep looking around. We're basically just killing time while the heat flow probe equilibrates, so I'm just playing. There's a close-up of the zoarcid fish. See if there are any palm worms hiding in here. I don't see any. We see scale worms. This is a very nice pink mat. They usually are white, but in this vent fields we've seen a lot of color variations from pink to white to orange, and the last time we were here, blue mats, which is something I've certainly never seen before. So our microbiologist friends will be very happy to come out and see some of these things, I think. Hopefully some of them are watching. And the wavy shimmering effect is because there is hot water flowing out here. The hot water has a different velocity of light through it than the cold water, so just like a desert mirage, you get this shimmering effect. So the autofocus and the auto iris are working much better than the last time I was here.
All right, I'm gonna push it down to see how far it goes.
No.
Oh, pull it all the way up first and then go back down.
Please.
Okay.
Totally out, and then
All right, bringing it out.
can stop the machine.
That's not bad. All right, that's fully retracted.
Okay.
Do I need to wait a second for it?
Yeah, wait for his word, please.
Yep.
They need to have a clean overall signal for the processing software.
That looks like perhaps a different type of xenoturbella. Maybe it's just a wrinkled one that didn't go through the fabric softener in the wash cycle. Oh, it's like, and lots of gastropods here. So let's see if we can get some good images of this. Oops.
Okay.
All right, I'm gonna go ahead and put it back down, see how far we can go in.
Yes, please. You don't have to go that slowly. Apparently, but this one it's okay. But yeah, it should go. Yeah, you're good.
Alright, once we get close though, I'll go slower just in case anything weird happens.
Can we get a frame grab on this and put reg or routes on the frame grab so you can find this?
I'm starting to push up a little bit on from the sediment. Is it all the way in?
I'll just wait a minute.
No worries.
Looks like it.
To what you're saying earlier. Yes. Shade.
We need them to stabilize, and then I'll let you know.
He came out and adjusted a bunch of stuff. So
Yeah. So much more responsive. It's much better.
Was in the same place.
see.
You mean the insertion? Yeah, we didn't pick up the ROV. Put it back in. So the issue was that the top thermistor wasn't in the subsurface, which we could tell because it was showing the temperature of water.
Yeah,
of
now
the
it's
seawater.
now it's starting to rise, so it means it's in.
Just so we know.
So, yeah.
Alright, so
Yeah.
alright, so we'll know we go about that deep to get everything and then safe as far as the stroke goes.
Yes.
We're gonna feel bad 'cause it's gonna add an hour to your day, but
That's fine. If you got all their thermistors in and it's
so basically go to the wrap.
yeah. Alright, bringing it up.
Okay. So okay, you guys are agreed that that's okay, and we don't
That's how we
need to
went.
mess with the
Yeah.
equipment.
Yeah.
Okay, great.
So we go to the next station then.
Well, so what I think we're doing is we're gonna move back to the north to find ourselves on top of the easternmost rock, and just on the other side is where we want to.
East of, I could bring it down.
So if we get back up here, what we want to do is get onto this line. So we want to get on top of that and then make the move to get out to there.
Okay.
And then that's as soon along this line as we can make a safe measurement. That's where we'll do, and then they will call out to you distances to move along the line for the subsequent measurements. Yeah, this is heat probe. Okay, now in making the move from here, and so we're actually there, we think, based on the offset. So making the move up there, if Z sees the place that we were trying to get to, then we might ask you to stop and we'll take a heat flow measurement there. But,
So you
that's,
think there's like a 10 or 20?
we measured a 30-meter offset to the south-southeast.
Oh, but before you go ahead,
Yes?
how about a push core for Ron in this place?
Do you think
do you
this is
think?
an appropriate place for that?
Or do you think it's not close enough to an active? Probably when we're
This
closer.
doesn't fit either the hydrothermal or the dead mountain. So no.
Okay.
Yeah.
Good.
Okay, so
I'm gonna back up
Based
so we
on
can
what I
get our.
read of what he
Okay.
wants, I would say no.
Okay. Well, I'll just keep that in your mind.
But
So,
the next stage,
the
all right,
next
so you
station.
gotta
if
retrieve
we're really-
the.
if we see some venting right at the base of the mountain, then maybe yes.
Okay.
So was what I just said okay for you guys as far as
Yeah.
getting there and getting on to doing the profiles?
Yes, that's okay.
Okay.
How long do you think it will take us to get there? Just to give you Rob an idea.
5 minutes.
Yeah, 5 to 10 minutes, unless Z sees where he wants us to sit down.
Yeah, I think we're probably gonna pass the west
The
of
next
that's
station, let's see what's to start.
rather than jumping forward, just do what you said.
Well, we got a bit of a mud storm. A common problem with ROVs. So Raquel, if you want to
Sure. Jump in for a little while.
jump in and do it on Espanol. Are those Z's glasses? Or?
Yeah, that's fine.
At least everywhere.
I can't leave my glasses in. If I take my glasses off, suddenly I don't know where anybody is.
Oh, me too.
It's,
Me too. Like I can see anything without glasses. I'm wearing like my contacts.
you got the contacts,
Does that
yeah.
also make you invisible?
Oh, yeah, right. Yeah, everything's safe as soon as I take my glasses off, right? Nothing can hurt me. Yeah, I've never had that particular perspective. But,
Yeah, I'm just,
one of
Yeah.
the most panicked times I had in my not too distant past was
Hola a todos en el live stream. Aquí reportando desde el Situation Room en el Falcor. Me presento, soy la doctora Raquel Negrete Aranda y estoy a cargo del equipo de flujo de calor del CICESE, Centro de Investigación Científica y Educación Superior de Ensenada, en Baja California. Y bueno, esto es para los hispanoparlantes que también tengan una oportunidad de entender lo que está sucediendo. El doctor Cares nos ha estado narrando de manera muy detallada todos los acontecimientos de este buceo. Y bueno, como ustedes pudieron ver, se observaron un tapete de bacterias muy bonito y se hizo la primera medición de flujo de calor. En este momento, ya que se liberó un poquito que se aclaró un poquito la imagen, vemos que están recuperando el dispositivo que se creó para checar que el sedimento sea lo suficientemente suave como para que no dañe la sonda de flujo de calor. Y estamos en camino a la siguiente estación. Entonces los invito a todos aquellos que tengan preguntas en español, que quieran saber algo. Ahora es el momento. Entonces el piloto va a colocar el dispositivo de regreso en su lugar y una vez que eso esté hecho, nos vamos a mover al siguiente sitio, a la siguiente estación, y hacemos la segunda medición de flujo de calor.
Can you rotate your jaw clockwise?
Se sienta, centro, pulso, fuerza.
There you go. There you go. And it's above the sneak. It's above the head. Yeah. All right.
Okay, while we're in transit, I'm just switching back to English because I see some questions on the chat. So for people that are asking what was that device, it's just like a poking stick. No, it's not a marker necessarily. It's just what we are using to make sure that the sediment is soft enough and that it wouldn't damage the heat flow probe, which you can't actually, unfortunately, can't see because it's mounted on the side of the ROV. So the actual probe looks pretty much like that one, but it's mounted in a way that the camera can't look at it. So I hope that helps answering that question.
Luis Ángel está preguntando. Luis Ángel,
Sí, ¿qué dice?
¿cuál es el siguiente punto de interés para la medición?
Ok, ahorita les contesto.
We're going to be using it a lot, so we're going to keep it up. It's not that it's going to be really hard. Because
Esto es de
it's in design.
Ok, entonces este va a ser un tránsito de aproximadamente 5 a 10 minutos, a menos de que veamos algo de interés para el doctor C o alguno de los biólogos que necesite que nos detengamos. De otra manera, el siguiente punto, para contestar la pregunta en el chat, es prácticamente muy cerca del edificio donde vemos una chimenea hidrotermal bien identificada, que ya habíamos muestreado en el 2018, y la idea es regresar a un sitio parecido, muy cerca del edificio como tal. Les recuerdo que para el flujo de calor es importante hacer mediciones que no sean dispersas, sino que sean sistemáticas. Esto es, que sean a lo largo de un transecto y que tengan un espaciamiento similar. El espaciamiento puede variar un poco dependiendo de los resultados que vamos a ir obteniendo, pero aquí la idea es hacer un transecto que va en dirección este-oeste, y que va a ir desde el punto más cercano a la chimenea hacia afuera del campo para ver la variación de la temperatura del flujo de calor en estos puntos.
I have a question for you.
But
You were out here in 2018. Is this cruise a direct extension of that one you're out here before, or is this doing something similar but different?
no, we're doing, well, yes, it's an extension, yeah. We'd only make one insertion point, well, one measurement, one station back in 2018. And so now we're trying to do the whole transect. So it's gonna start there and it's gonna go east, away from the bent field. Okay.
Yeah, what I'm saying is, he just passed two big mounds. I'm wondering if those were offsets. Like if we're actually here.
It wasn't the one that was on the east, because I had a nice flat top one. So it just past the westmost one, yes.
Would you get a fly with top of it? Little roll wheel or around?
So we just want to locate the top of that, the one that's on the east.
Gotcha.
We kind of sat right over and set the offset. Then once we're there, then we want to move basically due east to where that square is. Set down to a deep location. Yeah, there's the one now coming up with the solar.
I think this is the west.
Yeah, I agree. That's right.
Yeah, that's right. Yeah.
Yeah, those are all the slabs. We should be just about over that east one now. Well, maybe just behind us.
Okay.
Yeah, so
I'm right above the rock.
we're right over the easternmost one now, right? You agree?
But
Almost
more,
right under us.
yeah, there's something right. I can see the rock right underneath it.
Yeah, yeah.
It's right there.
3/4 of that square is roughly 16, 18 meters.
This one here?
Yeah.
Yes, so
So
that's where we want to go.
So a nice flat, flat spot near that square is where we want to start.
But the thing to understand is right now we're sitting on top of the rock, right?
Right.
So
Don't go by what the map says. Don't go to this part of the map.
well,
Go-
what you want to do is you want to drag a range and bearing from the center of the rock to that point,
Yeah.
and then make that move with the ROV.
Yeah, so right now, I want to go this far from where I'm right here, so I
See
want
what
to go
there's
to,
40 meters to the square.
right?
No,
I
no,
wanna
that's
go
not.
right there.
We want to go from where
So-
almost where the curve, yes, that's where we are. Now
Right.
So we're going right by here.
Okay, so you want to go 20 meters,
Yeah.
bearing 78.
Okay, when we get there, there may be a little tailless, and then, so we want to sort of, once we get to that spot, we want to move down the line to the first
Right.
nice flat
So
spot.
so then what I think that bearing will be about 109, but you should measure it on your map of the bearing along the line.
Yeah, you're looking along the line, it's going to be,
Yeah.
114.
Okay.
Alright, so you
So we make that move over to that point, and then we move along the line to find the first place that we can make a good measurement.
Roger, and you guys settle on that marker that you put down this way.
Okay, so I can transpose it a little bit if I go like this. I can go, what do we see, 78
Ándale,
20
Flora.
meters, right?
Quieren explicaciones en alemán.
Yeah, that's about right.
El cuate del chat
So,
dice que si el doctor Neumann no les puede decir algo en alemán para explicar. ¿En el chat?
Ah, ya, mi compa.
Ah,
Sí,
sí.
sí.
and then once that is 32 at 102.
Ay, gracias, mira. So fácil.
So let's see, I think to my east, so let's go.
What's going on there?
I don't know. I don't want to get.
So we're losing lights. Are you seeing ground faults anywhere?
Page 14. This guy here,
Page 14, that was
That's
the
the,
probe. Can you go back up on your map for 2 seconds? I can get a reference.
So what I did was,
Stable right now.
Ya tienes valor de rock.
Me está batallando porque no puede quitar. Pero vamos a ver.
That's not as good again, so just go with that.
So we've lost one of the lights on the port side.
That's the way that it looked when I came in.
anyways, so what I did was, when we were at that location, took the range and bearing to this place.
Yeah.
I took it from where he was to here, so he's
Yeah.
over that marker, and then I took the range and bearing from this square down to waypoint 1, which is now
Yeah.
this one here.
I agree. I think we're right there. That's exactly what we should be doing. I agree.
It's okay, it's just pull it down.
Alright, so bearing 111,
So
114.
yeah, so again,
Well, no, we are now at the point where we
so you
would
would
want-
be at the square.
Yeah.
Yeah. So
I put the
if we can do a measurement here, that's what we want to do.
And
right?
I think we can. There's a little bit of plan
Yeah.
stuff there, but if we
Yeah.
go between them, I think this is good.
So by and large, we might as well have the vehicle oriented at the 114, which we do, or 112, that's good. So we should set down and see if we can do an equal measurement.
Alrighty.
Ok,
So,
entonces acá vamos a volver a estacionar el robot para hacer una segunda medición de flujo de calor. El terreno se ve bastante amigable. Es probable que no tengamos problemas con la inserción de la sonda. Estamos trabajando todavía en obtener los resultados de la primera medición para ver si son más o menos lo que estábamos esperando.
Okay. So before you go ahead and do the test probe to be sure it's good, before we actually do the heat flow insertion, before you even turn it on, there's been some chatter on not chatter, but discussion on the Slack channel about how fast we should insert it. So I want to be sure we talk that over before you.
Yeah, we talked about it, right?
Yep.
So
Right.
around
10
10
seconds.
seconds.
But first, let's be sure we're
Yeah.
going to do it here.
Okay, you have permit rope?
Sure, thanks.
Rope on, Madam Karina.
No.
Ok, entonces ahí vamos de nuevo a probar la dureza del sedimento aquí para ver si es un lugar seguro, aunque aparentemente desde la imagen podemos pensar que sí.
32 watts per meter squared. Way more lower than last time, but still
What's
lying
that?
here.
32
watts per meter squared.
I mean, against 123, but we're not in the same spot. It's way high, but it's not extraordinarily
we're trying
high.
to find out what it is here, so that's what it is. Unlike,
Ok, vemos que la punta se está insertando sin problemas, entonces seguramente no tendremos ningún problema para insertar la sonda y hacer una segunda medición. It looks just fine.
Alright. Yeah, we decided to pull it out instead of leaving it because anytime I back up, it's just going to cause that dust. So,
okay.
alright.
Victoria's online. She likes the map. She wants to come back.
What's that? Got me moving the arm back?
Well, let's see how we can see it in the skin. Yeah.
Alright, can you get me right there? Yeah, I feel you.
Actually, I could just jam it in the ground.
Yeah, jam in front of us.
Yeah.
I'm happy here.
Okay. So, in the discussion back and forth between Florian and Rob Harris, who's onshore, Rob indicated that it would be better to insert the probe faster than we did.
Yep.
And I had been saying, well, you want to go slow and careful. So I just want to be sure that,
Sure.
that you guys agree on how fast you're going to insert it.
Yeah.
Yeah, it's in 10 seconds for the full insertion.
Okay?
Longer
Yep.
than 10 seconds.
All the way down.
All the way down till that's in there, and we can get to the very top.
Okay. And are you ready
Are
for
you
them
ready?
to proceed? He's in the right spot.
Okay, so
Okay, yeah.
I'm sorry, the skin can not even apply.
What?
is the probe on?
No, we had to turn it off because of
Oh,
the
okay.
Oh, okay.
ground faulting.
Switch
Yeah,
to
sorry. We were just trying to level out our
Oh,
downward
okay.
flow a little
Sí,
bit.
están estabilizando la ROV.
Actually, no, I don't know.
What's the first sign? Maybe it takes
It's going to be what per square
the
meter?
first. I'm sorry, it was
34.
34.
34 which, yeah, but it's still very high.
Yeah.
The last question mark? 34.
34 watts per square meter.
Watts.
So that's the.
It's the cube.
So
17. I can see fine right there. All right.
Okay.
Gonna turn the probe on.
Yes, please.
Is it science? All right, ready? Tell me when you're ready, and I'll start to insert.
Is the probe on?
It's on.
Oh, okay.
So you need to be recording for a minute.
No, just give me a second.
of course, you said there's no water flow right. It's not surprising.
All right, watch her roll. Yeah, I'm moving.
Just wait.
I'll stop.
Gary, are you up? Is it still up? Yeah. Okay.
I don't have anything.
Are you moving?
Yeah, I'm trying to go back down, but it's not stopping at all. Alright, yeah, that's good. It's a little bit of a...
But then you can start finish.
No.
No, but just to see the.
Oh, my depth.
Just to I have a time frame for the keyboard. So if you move around and I miss this time frame, then you don't get a good measurement. So we sit down, we wait, and I start and then you do this procedure. So we on the seabed?
Definitely.
Okay. We're on the seashell.
Yeah. Alright, I'm gonna come down.
Okay.
Okay. Are you going to stay put now?
Yeah, we floated off, but then it should be fine. That's good. Yeah,
Was that because you weren't thrusting down enough? Or?
yeah, we were thrusting down just a little bit because we got super hot last time.
We got
so we're
hot,
trying to
so
get
we-
it as delicate as possible.
Yeah, because we have to sit there for 7 minutes. We just want to try to use at least the amount of hydraulic
Okay.
fluid.
So now
Okay.
there's
It was good, but then it wasn't good.
Okay, so we're on bottom now, and you wait for a minute.
If you want to give us just a few more,
I give you the-
we need to wait until we can see in the skid to see what's going on.
Oh, yeah.
So,
Ya. También hay que esperar que se despeje la imagen en la. Acá no se ve por el sedimento. Pero espérate.
No, I do it again. So
¿Por?
es que estoy midiendo. Si no, ya no estoy.
No, pues entonces si pregúntale a la.
Are you ready to insert the probe?
no, because I
No?
can't see the probe yet. I'm not gonna insert it. I just want to know when it's all the way in or anything, or how fast it's going.
Okay.
Because we stirred up so much mud, it's to wait for the view to clear.
We have to redo it.
Just so I understand, Florian, you need when you start the measurement, you need to be static, and you need to wait for 1 minute before the probe inserts. Is that correct?
Yes.
Okay. But no more than that, because you can wait more than that. Like right now, we're waiting for that to clear. Then the measurement starts, and it's not in, so it's not a good measurement.
Okay, so that's what I wasn't clear on. So the timing sequence of this is he needs you to be static for a good minute, and then when he starts it, then exactly a minute later is when you do the insertion.
Okay, I can see now. Do you want me to move somewhere else or?
No,
Just
it's
bump
fine.
ahead over the snowstorm?
No,
It's fine.
because
Is it fine?
It's fine. I
Yeah.
can see it.
Okay,
so no, he just will restart the measurement. No worries.
Right, and then so a minute after he starts that is when he wants you to
Not
insert.
going.
Okay.
So we wait for 1 minute.
I will give you the sign,
Yeah.
and you can
So
insert
so
it.
he's 50 or 10 seconds in there.
Gotcha.
It's a little bit longer than a minute, but I will.
How longer? ¿Cuánto más de un minuto?
45 mediciones más.
45 me dijeron.
Son 1 minuto y ya, un poquito más. Cada medición son 2 horas.
So, when we do relay during that focal minutes, not exactly like 60 seconds, we do 45 measurements every 2 seconds on the thermistors just to see that they're re-equilibrating, and so that's why he will signal to us. It's not exactly a minute, but then we have, just to coordinate with them, we have to wait until he says okay.
Yeah.
But they can't take longer, and just inserting the probe after he says good, we're good. So it's just a matter of communicating.
Yeah. No, it's just we need to get into the cadence of it.
Okay, ready for insert,
All right,
please?
going down.
Yes.
Ok, estamos listos para la inserción y vamos hacia adentro.
Move it.
Se
It's
mueve.
bending. It's bending.
It's bending. Oh my god.
It didn't look like it bent too bad though. I pulled it out because it definitely.
Yeah.
Kicked up, so
Yep. That's the danger of going faster.
So we did hit something.
We definitely hit something that started to bend, but it didn't bend. It,
No, it just
it-
yeah. But that was good dive.
we have to go that fast?
No, you can go slower.
Maybe
Yeah,
go slow,
definitely.
because we can watch the roll of the vehicle, and as soon as that, if we hit any resistance, we'll see the roll of the vehicle.
Uh-huh.
And that
Okay.
allows us to
Yeah, so that is
See step?
completely retracted, but I did definitely hit something. I saw it.
Okay.
Sorry.
Should we move a little bit or?
Well, yeah, we're gonna wanna move and
Move somewhere
reset.
else.
Yeah.
Sure.
All right,
move
I'll
and reset.
I'll continue another 5-10 meters forward.
Yeah.
Yeah,
Please.
yeah, just
Yep.
go forward a few meters.
All right.
Ok, entonces lo que sucedió es que se insertó la sonda y encontramos algo de resistencia y vimos que se empezaba a doblar un poquito, entonces tuvimos que retroceder, sacarla y vamos a hacer un reset para volver a intentarlo en unos 5 o 10 metros más adelante. Okay, for English speakers, just to make an update. So we were trying to insert the probe, but we found something definitely below the sediments that resisted, and the probe was starting to bend. So we had to recede and pull the probe out. So we were gonna reset in a few meters, so we can give a second shot to this measurement.
Okay, so
Now we're out here.
so you think it's okay to be slow and safe, and Rob had indicated that he wanted it. Okay, so that was much
That-
faster than 10
that-
Because
seconds.
if it's slower, then we don't get the friction involved. And then
So we have to play
we need
between. If it's too slow, we don't create enough friction, but that was too fast, I think. And also maybe just bad luck that was actually something
Yeah, well,
right
right.
there, and right.
Yeah.
So it's in between that.
Okay. So let's just
Thank you.
make sure that we work it out so we can.
Alright, so we'll go, that was about a third of the way down. What?
Yeah, it was almost there.
Yeah, about 1/3 of the stroke of the code. And it took about 3 seconds, so for a third, so they're about 10 seconds for the entire.
Sure.
I'll go slower.
Yeah.
That made me feel safer.
No, and also there's the two boundaries actually are that you're going to go fast enough that you can create friction, because that's how we set the measurement, but slow enough to be safe. So yeah, so we just need to.
That probe just went in. It'd be about right speed, would you say? Well, we probably weren't watching.
Yeah,
The test probe, I think.
The test
went in
probe.
What I would say is a pretty good speed
yeah, exactly. Yeah.
between the two. Yeah.
Yes.
Okay.
I mean, if you really carbonate or something.
Yeah, so I'll watch the video. He'll watch our roll, so he'll know.
Okay.
As soon as something comes up.
We don't have force feedback on this, but it's almost like there's like a layer in there, like a felt vehicle up a little bit.
Are we moving? Are we moving?
Yeah,
Oh.
we're moving up a little bit,
Okay.
yeah, just so that I can get up to where he had just tested that.
Yeah.
Yeah, I wouldn't be surprised to see the clamshell.
Oh my God.
Clamshells.
Yeah.
Yeah.
Yeah, there certainly are. How long do they last? Yeah, we're well below CCD here.
I don't know. It's a good question. Maybe.
And maybe they last a long time if they're buried.
And more water diagnosis usually makes more sick.
Okay.
And it starts to disappear until you get to sulfate reduction, then it goes back the other way. So no, they probably disappear, I'm guessing, 10 to 50 years.
Okay.
Maybe, probably closer to 10, but I don't know. I wrote to Mandy, enjoyed to see her. She would share her data with us. Her background in it.
How's Mandy doing?
Don't know. She hasn't gotten back to us.
Alright, so we're down, but we're not.
So we wait a little bit to
Alright, I'm gonna lock it right there.
so we can see the growth.
Yeah. Yeah.
So the upper right view labeled bullet is on top of the ROV.
Yes.
Yeah,
We'll
it's
get back
looking
in.
from our heading back towards the ship.
Okay.
It's starting to clear up.
Yeah.
So what the thrusters are spewing out there is just muddy water. The reason that we
just-
can see it.
Yeah,
Okay.
so all of the sediment that gets on the ROV, whenever I sit down, whenever I get up, it kind of comes around. That's just moving all off.
Okay.
Okay. No. Are you? So are we ready for the
I'm
next
ready
one?
for you guys whenever
Okay.
you're ready.
So we're ready for the next one.
I'll watch the video.
replaceable.
That's it. What?
Cool beans. What does it mean?
It's my metal for.
I don't know that as
An
an
expression?
idiom. Yeah.
No, me neither.
I'll just presume that I'll take the cool.
Yeah.
It's from the competition we did for cycling, rowing, and running. We came in second in our group.
Because I'm sharing the screen from
Second overall.
What? It's out?
Yeah. Either one of them.
What did you say? I didn't say.
Okay, you ready?
Ready.
Turn.
Nice and easy. Yeah. Yeah.
Yeah, so let's start with that last time. It's looking good.
Looking good, looking good.
Good. Alright.
Okay.
Yeah, looks good. Thanks.
Yeah.
Man.
That was good one. Thank you. Ok, bueno, éxito este segundo intento para insertar la sonda a la velocidad correcta para que se genere una buena fricción entre los termistores y el sedimento y podamos dar inicio con la medición, que de hecho ya va en curso. Okay, for the English speakers, success this time. The ROV pilot is a rock star and he just hit the right speed to insert the probe safely, and so it seems like it's going to be a good measurement.
Este lo que dice Juan, que si queremos más, que necesitamos un punto más robusto.
So here I just
Estamos en el lugar de... Are we exactly where the 123 watts per square meter were taken on the 2018 site?
I'm sorry.
I remember we just got on one measurement back in 2018, it was 123.
Right, but we were not at that same spot.
No, not for another matter.
Yeah.
That's what I want to make sure. Still
Yeah,
pretty
and
high.
we were within probably 20 meters of the spot, but at a different map.
Okay.
Yeah. And when we were at the other map, we were actually closer to where the venting was. So it was a different map, but it still had venting just like inside.
Right.
We were closer into that, so it all fits together very nicely. This is 34 and that was 2029.
Okay.
Yeah. Because it's going to be really patchy with those bands.
Right, right.
Yeah. But 34 is a very reasonable value, I think, for where we were relative to that hot water coming out.
Yeah, as you're asking me, you can see now since all that mud that was on this is gone. It's just
Did you do a thermal com with the first one?
no, you couldn't get very high temperature. So
What
this
was
one is looks
the
very good.
concern about running too hard on the hydraulics?
our motor temperature and hydraulic temperature shot up and that whole thing was overheating.
Really?
Yeah, whenever we sit in one place
Uh-huh.
and use our thrusters to keep us there, just because the oil just goes to a certain level and it's up. And until we do something
This would
else,
be around
get up,
7 watts, I
move
think.
something else around, it doesn't cool down. It's all that oil stays over here. Hot oil goes to that same circuit.
Okay, for
So So the problem is actually that you're only running one of the thrusters or two of the thrusters.
One circuit, yeah. And it just
Okay.
constantly does it, and so we have to, if we're gonna be down.
All right, so good because you have to keep the HPU going, but you're only using a small amount of water. Okay. All right, that's not something we're.
And we were fine for a minute, and all of a sudden, it sort of floats away, and then we try to come back down.
Yeah. Okay. It's an interesting problem. I'm much more familiar with pilots yelling at me because I'm hitting the thrusters way too hard as we try and run surveys. So.
A little bit nice steady, keeps us sure. But I've never really had an issue with it this deep before, so that was crazy.
Yeah, it was weird that it didn't work though.
Yeah.
It's too greasy. Yes, you can
High temp 1.9.
Estamos como a 20 metros del sitio donde medimos 123. Era un mar diferente y había fruto, cositas que, 70 qué.
Right there.
Can we disconnect the wood? So the screws on yours don't have it supposedly.
Yeah, that's true.
Like if you look at the way you put to the bottom right corner square there, it's not working.
But we're just 2 over 2 squares, just over 2 squares. That's pretty good. Yeah. Fall team challenge 2021. So, too hard.
Apenas vas a ver todo.
Y luego vamos a esperar 5 minutos. Ahí está.
Ok, no se duerman, seguimos aquí transmitiendo en vivo. La medición sigue en proceso, ya se lanzó el pulso de calor para ver cómo decaen los termistores, la temperatura de cada termistor. En unos 7 minutos podremos finalizar la medición. So don't get too bored, don't get too comfy. We're still here, streaming online. So the measurement, the heat flow measurement, the second one is still going on. We just fired the heat pulse, and we're waiting to see for 7 minutes how the thermistors decay, so we can actually define some of the thermal properties of the sediment, and the measurement will be finished in 7 minutes, around 7 minutes or so.
just to make sure they fire. Whether they fire it or not, I take it apart.
Ah, yo pues eso.
So there's no reason not to. I don't know. It does take time to pick up the fire. That's too much time. Fire will explode.
Any other question, I guess, would be another, a little less than an hour and a half left. So we might get a couple hundred meters away, but much more.
Yes, I think they much more fire model.
So that's firing the model, probably 5 minutes away, push forward. So it's to stop at 10 or 6.
Yeah, that could fire this model way out. I mean, wow, but the drop it.
Yeah.
They can tell us, so I don't like doing that.
If you wanted to, but
I'd rather not.
neighbors here.
Yeah.
You know, we'd say that they were expensive, except that they're irreplaceable.
Yeah, but she told me they're like $5,000.
I think they're more than that.
I think about even the 10 grand fees for insurance purposes, but you probably get paid for 5. I'm not sure if you get paid for it.
Well, that's the problem. Is
There are better systems now. They're more complicated. You probably work with Jeff Seawell system.
yeah, he's been out here.
Yeah.
What is this?
So they're more complicated to use because they've got power. They have
So
a conductive
the next
coil
decision is going to be how far you want to move.
communication
Down the line.
to the bottles. So
we
they're
are
pumps
already
to pump the seawater
in
through.
the
And
Well,
then
we are
verify
50 meters
it's
out.
measuring the temperature, right?
Or no, we are
And then, you turn it
We're like
around.
10 or 20 meters away from the square.
The reason we use.
Right. So we tried to get to here,
got the gas
and then we wound up, we had the field measurement, so we're a little further, we're like there.
Okay.
chemistry they want to do.
Okay, so further down the line.
And that's, between these dots is 50 meters. So the question is how far down the line.
Is it
we
waypoint
wanna
number
move.
1?
Built to be,
Or we are
Where you are is about right
Estamos un
there.
poquito offset del
between
cuadrado.
41 and 1.
No, where I'm pointing is about where you are.
Build these other bottles.
Where I am,
Yeah, but in terms of waypoints,
this is what they labeled as 1. This is what they labeled as 0. So in my list, this was the first number.
Right.
That's the second number, and we're kind of halfway in between those.
How far do we want to move down the line? 50 meters.
You can do everything on one sample and it take 3 or 4 bottles down. You just move the inductively coupled wand to both better temperature quicker from one bottle to
Just
the
the
other.
one that you just pass by.
And so there's a little cone up top. Put the ring over that. Picked up a bottle, put it up, put the ring on there. And then you can communicate with it. Put the bottle back. Take the ring out. Get another bottle. Put the ring on it. So they're not hardwired into the sun. Otherwise, you
Yeah, you
need
need
4 or 5. So you use that one interface.
And so it's measuring that in real time, it's setting that up to a surface,
Yes.
and that is your sample.
Yeah.
You're already getting the data from it.
Yeah, you're getting the temperature data, not real time, but also
50
as
meters
it's coming into
down the
the
line.
So you put
So we're
for-
close to be
that-
done, and
the
we
two
will
that
want to
pump,
move
you wait till the temperature
50
stays
meters
later,
down.
and
But I'd
then
let you know
just
when.
flip the
Oh yeah, I'm just gonna measure it out.
okay, we are
So
ready
now you know
to get the
you're
probe out,
getting
please.
the same
All right.
temperature. You're
We're tracking the
comes in. Whereas, measure temperature one place, try to put the probe in, you don't know. Yeah. So, yeah.
Yeah, more accurate.
Yeah. And they're really nice bottles.
Ok, pues terminamos la medición, estamos retirando la sonda del sedimento. Vamos a continuar con el transecto de flujo de calor al siguiente punto. que va a estar 50 metros sobre la misma línea, sobre el mismo echado que tenemos.
Great, Jeremy. That's enough. Oh, I'm pretty good. I already had a mark right there.
Wait, thank you. Thanks, sir.
Okay, so it's in the middle of the ROV and the marker that's there. You ready?
Yep. Okay, so we're moving again. We're heading towards the third station. That will be 50 meters down the line, down the transect, with the same bearing, just 50 meters away from the one we just did. So,
Is that a picture going? That might have been a newspaper going.
I want to go relatively quickly so we can be up there. If there's anything you want to look at closer, just yell at me. I'll stop.
okay. So he's gonna move a little bit faster. If you see something, maybe you wanna take a look. So,
I might want to.
if you see something along the way, he's gonna move relatively quickly, transit to the next.
Yeah, I don't want to stop.
No,
Unless there's
I know.
something really good, I won't stop.
No, yeah, okay, you're good. You can move.
They'll show. TD.
As far as it's
161.
And more to do.
the big bed fish with a bunch of those on the skin.
It's about 50 years away. Yeah.
Yes. They show up really well until you get in there and you get really
Yeah.
like a fish.
All right. It's just about 50 meters right there. All right, heading correct.
So I don't know what you think, but I think out here the chances of hitting carbon hard ground are pretty slim. I don't know if we want to keep probing or not. I think if we just watch the probe, I mean, it's your call, but I think this far away.
Right,
So
yeah,
you decide how safe you feel.
right, right,
Well, just say, a couple of minutes to station.
right. Yeah, let just let me take a look at the sediment, but yeah, definitely looks like. ¿Lo quieres seguir poking? Aquí estamos lejos de los carbonatos, ¿no?
So no on the probe? Or yes?
I think we don't need to do that here, but
Are you on bottom now?
I am.
Okay, on bottom?
I'm on bottom, but I still can't see the probe yet,
Okay.
so.
Okay. Is the probe on?
Yeah, it's going on right now. Are you ready for it?
Yep.
Full probe on.
Probe on. Yeah. No, right now. They just.
Yeah.
You want to play with the camera while we're sitting here?
No, please do. I'm just gonna moderate that we're starting the third measurement.
My understanding
And then
is
it's
our
all yours.
time is 6 p.m. local. We have two things we want to do.
Okay, get ready.
We can go with the insertion.
Insert the probe, please.
Ready? Inserting.
Ok. Estamos de regreso, estamos en la tercera estación y estamos insertando la sonda en el sedimento y todo va bien. Estamos a unos centímetros de enterrarla completamente. Ok.
Thanks.
Bueno, entonces damos por comenzada la tercera medición y en un ratito más volvemos. Okay, the third measurement's on, guys.
We also want to test trigger and so my guess it'll take 2 minutes.
Take the camera.
Is that about right?
I mean, I guess we don't want to vibrate the vehicle right now, so we can try and measure right now, but we have to torch out.
No, we want to do that.
Okay.
But so I'll figure on breaking off this stuff. Well, it kind of depends on how it works out, but I'd give it about 10 minutes ahead of 6, so we'll do those last two things.
Maybe we can, John. We can put this. You got it.
I think they fight a psychic. Morning, Ben. How are you?
Alright, man.
Oh, coming in?
Hold on.
Okay. So right now we're on the seabed. We're in the middle of a probe.
Okay.
Probe's down. Good view of it right there.
Down is up. I'm not touching
Yeah, bring it right for you to retract it.
Okay.
Push it away, put it in.
Okay.
We're not necessarily using the reef rope. We did it for the first couple times. This last time, I don't worry about it. It's a comfortable with our distance or anything that might cause problems. Okay. Although a couple insertions ago, we did see certain events. We stopped retracted and didn't do anything. So that this just started. So the way that we're doing it right now, we're on this relative line right here. Okay. The offset. We went 50 meters this time. I'm not sure if we're going to do it again, but whatever. So 50, how far they want to do it. Come down, if we do a certain test, and we're going to put text to it. And I think it's still where we are. So we're doing it all the way down to the boulder is actually inside the seabed. Because that gets all of the distance.
So you're taking the actual
All the way
boulder all the
yeah,
way down.
yeah, all the way. You'll see it when you bring it out. Okay, that's good. They want it from the beginning of the insertion to all the way down to 10 seconds.
Okay.
So just steady. Just keep an eye on that. Make sure that
Yeah, so
keep an eye on the roll. Just make sure
I just call it roll in if it's 30 pitch, we just small stop. Okay. The other thing is we have that blue here, that thing. Stop. So the instruments. So just four bowlers. Then we just have it 3 times the next 4 or 5 minutes. Don't think out. Yeah. But we also second break all the lights. So
we were far away. We get there. I don't know where the ship is.
ground fault. No ground faults. Check all the breakers.
Oh, there it is. Okay, so right now we're don't bring it on. Figure out.
If there was. Anyways, it'll stay. Keep an eye on it. Yeah. If you guys, you'll know what happened.
You guys are in at 6 o'clock, which you probably will be. By 10 minutes before start to recover. We're up here set up for a push core and test fire agent.
Okay.
So, yeah, so, in about an hour or so.
Okay.
We're just doing that.
Okay. Sounds good, man.
Yeah, and as far as these results go, right there, that's this was what they said. Push core, a major. A little off the 14. Heading about 14. Okay. Okay. Is it just this offset right here? Yeah. Yep.
Thanks, guys.
Yeah, all right. So you'll be I handed over just for something should be okay, but make sure that it is like
Okay. Okay. Thank you. Thanks.
No, that's good. Yeah, 2,800, 2,000, somewhere around there. Thanks.
Have a good day.
So we're just sitting here waiting for the heat flow measurement to end. So just playing with the camera. This is what's called a sea pig. I think it's a type of holothurian, if I remember right. And we saw some anemones and some big flat holothurians, and something purple, I think, was an urchin in the distance that I could never focus on because the autofocus, when it was pointed that direction, always went on the particles in front. So we're just trying to keep ourselves and you amused while we're collecting data. And I'm easily amused. Oh, there's some isopods or amphipods. I'm going to guess amphipods, and someone can correct me and tell me I'm wrong. What's the wiggly thing? Those are holothurian feces. They look like squiggly little curly fries. I'm not sure I want to eat one. Yes, they are fecal casts. I'm pretty sure those are from the holothurians.
Are we doing just another 50 meters after we do come up?
What's the next exit?
Yeah.
50?
I think it will be, the next one will be also 50 minutes. Yes.
Okay.
Yes.
Thank you.
Yeah, you want to head from where you are 50 meters along the same bearing as that line.
Okay.
You see the offset. So I think this one. They can measure that bearing at 112 or something like that.
112?
Well, but feel free to go up and draw a line,
Yeah.
drag it along the line up there. When I laid it out, I think it was about 110, but when it was measured on your screen, it was about 112.
So this one gets my vote for the cutest critter in the field of view at the moment.
That's 110 for that other mark. 50 meters? 110. Very 110. Yeah, that one was here. 110 meters.
Where's the range of the
50 meters, you said?
Yeah. Does that seem like the display?
51.68.
Oh, there it is.
But experience, ¿no?
Okay. Yeah.
¿Eh? ¿Tres? Porque digo que ya la siguiente, esa dos va a ser baja.
One thing that is a little curious is right here there's except I'm not going to be able to focus on it, I don't think. There's an empty tube worm tube. And the tube worms live over on the mound, about 150 meters from us, so it could have been blown here by the current, or somebody could have brought it over here to eat it. I don't know. But I did notice that there was a Oasisia tube worm tube that was empty from a dead tube worm out here. And the Oasisia only live on the hydrothermal mounds where there's enough fluid flow to bring hydrogen sulfide to their symbiotic bacteria. So they don't live out here in the sedimentary flatlands. And there's a little polychaete. We'll see if we can. He's not in a very good position. We'll see if we can zoom in on him or her. Come on, pretty Polly. There we go.
So you're ready to pull out the probe, please?
Okay, probe coming up.
Florian.
Once it's up, can I turn it off? Sure. Now you can turn it off. Yes. He's gonna you're done to turn it off again. And then you're about to start turning it back on. Okay.
And I believe this is the similar isopod that was identified earlier. Not something I'm very familiar with, but someone identified that as an isopod earlier, or at least something that looked like it.
Have they been turning it on and off? They've just been leaving it on, right?
Yeah,
Yeah.
You can turn it off if you want.
But then we just have to remind you to turn it on
Yeah.
the next station, so it doesn't make sense unless you have a reason to turn it off between
It's
stations.
just that we have let me just go ask you guys, because we have a slight problem for
Ok, terminamos la tercera medición, vamos de regreso, bueno, continuando con la cuarta estación.
Sure, yes.
Sin-
Yeah, sure.
Yes, ready.
Once the probe is out, we can move.
Okay.
No problem. Thanks.
Perdón,
This one we do without the people, so
aquí nos interrumpimos en la conversación. Terminamos la tercera medición y nos vamos a mover otros 50 metros sobre la misma línea para terminar el transecto. Las mediciones han ido cayendo de un valor aproximado de 34 watts por metro cuadrado a lo que calculamos en esta va a ser alrededor de 3 watts. Entonces vemos un claro descenso de la temperatura del flujo de calor conforme nos alejamos de los campos, del edificio, ¿no? De la chimenea hidrotermal. Le quiero mandar un saludo muy especial a mi sobrino Iker, que está por ahí en el stream oyéndome. Hola, pelón. Te mando muchos besitos. Okay, so the update is that we just finished the third station, and so we're moving another 50 meters along the same line with same bearing for a fourth measurement. So just for you to know, the first measurement was 34 watts per square meter, which is a high value, near one that we did in 2018, which was 123 watts per square meters. And we are actually looking what our expectations were in terms of the heat flow value descending as we go away from the bent field. So now, on the third station, we moved from 34 on the first to 9 on the second to 7.5, and to what seems to be gonna be around 3-ish watts per square meter. So I think we can foresee that our next station will be near the heat flow background value that we determined for another vent field not far from here, which is 2 watts. So we will see what happens on the next station. Stay tuned.
Rich, you have any position? Update, thank you.
Are we there?
So, Rico?
Yeah.
It was just pointing out that question there. Can you still use the first measurement, or is it too bad because it was inserted too slow?
Okay. Yeah.
It works.
Okay, addressing one of the questions on the chat, Tim asked us if we can still use the first measurement or it was bad enough because the way the probe was inserted. And the question is that it wasn't the highest precision of measurement, but it was still useful. And we're pretty confident that the value that we got from that measurement is accurate. But it's a good point, Tim. Thank you for noting.
Oh, I see. If it all works out, yes. Otherwise, we could just defer the whole thing to the next day and do something else to it. But
¿Cuántas mediciones tenemos en los transectos? ¿Cuántas mediciones tenemos así como en total que queremos hacer, así como una pelota?
Pues yo creo que esta y otra ya. Luego hay que
Subir y luego van a hacer otras. Ponle, o sea, por transecto 10, dirías. Así como una prox.
¿cuál se va a hacer?
Esta va a ser la cuarta.
Bueno, ahorita hay que ver cómo va.
Ujú.
Como no sé, esta vez. Se quiere.
Okay.
2.7.
3.7.
2.7.
¿Dos? ¿Ya?
All right. So we're in
Are you ready?
we're now.
Okay. Well, you're it's clear, right? It's clear enough that you can see where you're going to start.
Yes.
Yes.
Can you turn on the probe, please?
Can you turn on the probe?
Probe's on.
Probe's on.
Yeah, you can see that right there.
Ah, yeah. I'll give you the signal when you can go in. I think we're approaching background heat flow very fast. The last one was 2.7.
Oh, 0.7.
2,
Oh,
2.7.
In background's not 2.2.
Yeah,
2.2.
right. Yeah.
Cool.
So I think this one is gonna be, and we're not gonna measure the thermal conductivity, so it's gonna be faster. So I don't know if it's worth to go another one, like 100 meters away maybe, just to make sure that
Yeah.
we're wrapping
Yeah,
things
you,
out
you
of
don't
the-
want to come back on this line, so yeah, you might as well be sure.
Right. Yeah. But I'm just thinking about the spacing. If we are really hitting the heat flow background, which is not far from the last one is 2.7. If we get this one at 2.2 or so, yeah, we might as well, space it a little bit furthermore. I don't know. It would
Yeah, that makes
probably make
sense.
sense.
The other thing, at some point I tried to draw that line much further when we would want to go. So at some point when you think we're down to background, we hop up to the other line and start working our way back towards it.
Right.
Well, probably only get 2 more measurements, right?
Well, this
Insert the
one,
probe, please.
Insert the probe, copy.
2 to 3. Yeah, we should get at least 2, and we'll see.
Yeah. So maybe just work coming up there if we get a car.
Yeah.
Right.
Yeah, that is a point that maybe we just keep going on this line, and if we get into moving up to the other one, there's perhaps a little complexity in
Yeah,
talking
a little bit faster, a
through
little bit
getting up
faster.
there.
At one point on one line, you got to go back to.
Okay, that's fine.
I think I would just continue this one.
Yeah, I agree.
Yeah.
Okay.
And yeah, I mean, we don't have to do the other lines as far, so it's started moving 100 meters.
Yeah. 100 meters, I think. Good.
Okay, let's
Did
go.
you went all the way to the
Oh,
bottom? Thank you. Looking well? No, you play. You're the one who plays with the camera. Very nice.
It's okay to take camera.
Yep, all yours.
Flora, or are we going to do another 50 meters?
Yes.
¿Seguro? Pregunta la voz, yo creo que nos podemos enseñar.
I will need to take a look. Let's see. So we are
Anyway, it's a
45 minutes.
Bueno, podemos hacer dos más.
mamá.
O sea, podemos hacer
Esta y
esta
otra.
y otra.
Porque eso no va a ser competencia, va a ser una una completa y luego yo creo que
Ahí sí podemos hacer un espacio más grande, ¿no? O dile que si no vale la pena, ¿no? Ampliar la especie para la siguiente.
So I need to go work on the night program because we're running late. We've got some little hitters now, which I got to sort out.
Sure.
So for the rest of this, finish here, you're going to move 50 meters more. Is that what you've set up?
Yeah, we were trying to find out if it's going to be 50 meters or 100 meters.
Okay, so your choice is 50.
My choice is 100, but Will
Okay.
says 50, and so we're going back and forth
Okay.
a little bit.
All right.
But yeah, we aim to do the next one complete because we're going to cut this one short. We're not going to take the whole 7 minutes after the heat pulse. So this
Okay.
one will go faster, and then we decide for the spacing on the next one and another one, and that will be perfect. So wrapping things up.
Okay. And you'll do another 50 meters, another 100 meters, or?
Probably, I think that what will say, and he's talking to Brian right now, but I think he will say another 50, and then the next one, 100 meters.
Okay. And then we're done. We just continue down this line and go, right? Okay.
Yeah.
Great. Well,
Unless,
I'm just,
unless we have more time, which I don't think.
I think it's going to work out, and we want to give Steve 10 minutes to. Well, we want to do push core for Ron, and then we want to let Steve trigger. And so we think that'll be 10 minutes. So I think it works out to do those two more.
Okay. Okay. But did we write that?
Yeah. I'm just going to go over and work on the multimeter. So, message from Ron.
Oh.
Hello, Ron.
Yeah. Hey, Ron.
No, don't move. Don't move. You're fine. Look what the spider is doing. So nice to join us, Dr. Ron. Finally. Everybody says hi from here, from the control room. What do you think? Nice spider, huh?
Isopod.
Isopod. Sorry.
And that's a Oasisia tube. It doesn't live here. Again, it's been either blown by the current or carried here.
Right.
And I think the little guy's an amphipod, but someone can correct me. Monopsodea. Was that the what was the Monopsodea? The unknown explorer Lisa said that we have a Monopsodea, but I'm not sure which one we were looking at. Was that the long spidery-legged amphipod?
Oh, yeah, we can turn it off.
Yes, apparently the isopod is the Monopsodea, according to unknown explorer Lisa. Thank you for that.
I thought like that's why I ran it. It's really like late right there. Just got it. Yeah, I came. I'm gonna sit here now. This is down here now. What's that? No, he texted me. Can you come here? Nobody ever answered. Can you come? It's actually.
Okay, anybody want to identify that? That looks like a dead thing to me.
I concur.
I don't think that is trash. I don't think that is human stuff. I think that's just a dead thing, but I defer to other people. Let's see what Mr. Shrimpy's doing here. Oops. 2 Mr. Shrimpies, 3 Mr. Shrimpies.
So get the probe out of the
Or
sediment,
Mrs.
please.
Shrimpy.
Bringing it out.
Yes.
Coming out.
Thank you.
Looks like the shrimp has found a tasty little lunch there. Not nearly as tasty as the food on the Falcor, however.
Great job with your position.
Thank you.
Thank you.
Another 50 meters, please.
Another 50 meters, copy.
Thank you. Can I turn off the eco?
Yes.
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 Answered the wrong question.
Ok, bueno, terminamos esta tercera medición, vamos por la cuarta o la quinta, ya me hice bolas, pero bueno, vamos a movernos otros 50 metros. Esta medición fue un poquito más rápida porque no tomamos todo el tiempo para medir la conductividad térmica. Entonces vamos a movernos a la siguiente estación, ahí vamos a hacer la medición completa y estamos pronosticando que vamos a estar muy cerca del valor de fondo de flujo de calor, que en esta área es de 2 watts por metro cuadrado. Entonces estamos en tránsito a la siguiente estación. So we are in transit for the next station, which is going to be another 50 meters away, following the same transect. And we're waiting on the results from this last one, but it seems like it's going to be nearing the background heat flow for this area, which is 2 watts per square meter. So we will see what happens in the next one, but stay tuned as the results are being processed live and they come out pretty fast. Sin poking, ¿no? Sin poking.
A menos que se ve raro en el fondo.
No, pero
¿Tienes
no.
alguna otra forma? No sé.
Ajá, sí, pero no, está... Bueno, hemos llegado al sitio y los pilotos están estacionando el robot para continuar con la medición. So here we are on site, and they're just parking the ROV on the bottom, so it gets nice and steady. So the transect will be, originally was planned to be a few more measurements, a few more stations, but looking at the results, it seems that if we hit the background heat flow, then there's no reason to continue on this direction. We better jump up to the next transect.
Are we down? Yeah, it's on. I will wait a few seconds to get the dust away from the flow.
Yeah, actually, we're looking at the skid cam. If you're looking at the skid cam view, you're looking at the actual probe, and we were just waiting for the dust to clear so the pilots can go ahead and insert when it's clear enough.
We're ready whenever y'all are.
Insert the probe, please.
Inserting the probe.
So there you go. Yeah, so it's
Yeah, nice. Go.
very nice speed. Go ahead. Almost there. Oh. Perfect. Touchdown. Well, that really won the.
good.
That's
Nice.
perfect. Yeah. Thank you.
No problem.
Y próximamente se contesta. Y vamos a verlo completo. Creo que ya se terminó.
Sí, yo creo que sí. Bueno, no sé si depende que nos apuramos, igual podríamos. No, ya no tiene mucho caso hacer, pero a lo mejor podríamos hacer la primera de la siguiente.
No, no creo que termine. Pero eso vamos a tener mucho tiempo para que se termine más.
Are we going
So
another
the
50?
next one is 100 meters away. Please.
Awesome, thanks.
Marina, todos preguntan por ti que dónde estás. Si no estás aquí.
veces hicimos un error y todavía no queda todo.
Tan buenas estas sillas para el laboratorio.
Pues está bueno de laboratorio. Pero yo creo que yo sí de compras 3 o 4.
¿Cuánto crees que haya sido el anterior?
1.9.
¿Cuánto?
1.9.
1.9.
Así que la anterior era 2.10.
Who's hungry? Why don't you have dinner and just go to the line? That was the first one done.
That's a real.
And you're not eating. Not really. You think so?
Okay, probe out of the seabed, please.
Probe out.
Sorry, can I shut off the report? Wait a second.
Entonces, ¿qué le hiciste si te también?
Okay, thanks. General.
Ready to move?
Yes, please. Ok, terminando esta estación, moviéndonos 100 metros ahora a la siguiente estación. Aquí con con la compañía del amigo pez que dejamos atrás. ¿Cómo estás, Ale?
¿Cuántas pruebas llevas ya?
Vamos por la quinta apenas.
La quinta. Okay. ¿Cuántas van a ser hoy?
Pues yo creo que ya no nos va a dar tiempo de hacer más que mejor esta. Y vamos a hacer un push core aquí en el core. Y también creo que sí quiere lanzar una de las botellas.
¿Esa qué es?
Es para muestra de agua.
Ah, la de las de abrirle.
Sí,
porque se llena.
para que se llene.
Ajá.
Entonces,
¿Por qué no da tiempo? ¿Porque el Sebastián se calienta o qué?
no, lo que pasa es que los pilotos
tienen que estar-
lo tienen que regresar a cierta hora aquí a la superficie. Acuérdate que se lleva 2 horas subiendo.
Sí, claro.
Entonces,
O sea, de noche no se puede.
pues no lo prefieren. Además, la idea era que hubiera estado aquí a las 6, o sea que nos dieron este margen por el retraso que hubo por el problema en la hidráulica en la mañana.
Sí, no sé.
Entonces,
Esos bichos que parecen estrellitas son todos viajes sin lentes.
¿los cangrejos dices o los que?
Sí, los cangrejos.
Los cangrejos, ya sé.
Sí, porque cuando se acercan la primera vez ven los cangrejos, se ven como estrellitas, ¿no?
Sí, hay unos bien bonitos, la verdad.
Sí,
Hay
no,
unos-
está increíble. Está increíble esto de que o sea, yo sí quiero entender o saber dónde lo busco.
Ajá.
¿Cómo es que mides la temperatura por watts por metro cuadrado? O sea,
Ajá.
esa es nuevo para mí al 100%, o sea,
Ok.
nunca lo había ni escuchado. Entonces, ¿cómo funciona
Lo que pasa es que tú cuando haces una medición puntual de la temperatura, entonces ahí tienes una medición en grados centígrados o lo que tú quieras, ¿no? Pero aquí como lo estás haciendo con varios termistores, lo que estás midiendo en realidad es el gradiente,
Por eso
La-
es largo, para que tenga...
porque tiene termistores a
¿Qué
determinados
es un
espacios.
termistor?
Es un termómetro. ¿Ok? Es un sensor que mide la temperatura. Entonces, los termistores están a cierto espaciamiento y cuando tú mides, a lo que tienes es una especie de curva, dónde está más caliente y dónde está más frío en ese espacio, ¿no? Entonces, ese valor del gradiente lo multiplicas por una de las propiedades térmicas del sedimento y te da entonces este valor de watts por metro cuadrado, que es el flujo de calor.
Y la curva que él tiene ahí es cada una de uno de los diferentes
termistores.
de los diferentes
Colores, exactamente.
Pues es un sensor de temperatura al final.
Sí, son sensores de temperatura, además que lo que importa es el arreglo y luego el proceso matemático que le haces a los datos, porque al final se hace lo que sea una inversión de datos. Tomas el gradiente, tomas la conductividad, lo metes en un programa, que es un código que tú, bueno, que nosotros hacemos para inversión y que te da como valor este flujo de calor. Entonces, lo tienes que ver más, no como un valor puntual de temperatura, sino como más bien como un valor de transferencia de flujo de calor de manera conductiva. O sea, cuánto calor se está transfiriendo de un punto a otro, ¿no? O sea, como cuál es es como yo lo entiendo mejor, ¿no?
Sí.
Por eso tiene esas extrañas unidades.
Sí, eso, pero están muy poéticas, sonoras.
So last station was 1.9.
Okay.
So we're expecting this one to be even lower.
1.4.
1.4. This one. So we're heading to the one that's spaced 100 meters away.
Okay.
And so when we're done, this is going to be a complete measurement. So it's going to take.
Okay. Do we have time for that? How
Yeah,
long
yeah.
is that
No,
taking?
no, yeah. It's we're right on time, and,
Okay.
and then we do the push core and the
And the trigger.
and
yeah.
the trigger.
Yeah. Okay.
And I think we'll be like right on time with
Okay.
that. So at least something was right on time. Like it wouldn't have any more sense to go further down this line, after this station. So it's just like perfect timing to go back.
Yeah.
It doesn't make sense because it's already in the
In the background, and it's not gonna vary much from now on. We expect it's gonna probably.
Unless we run into another hydrothermal. That
Oh, yeah,
field
unless
on the-
yes,
yeah.
of course, that's
But
always.
we
a
don't know
poss-
of any out there.
No,
In
but
that
it's always a
direction.
possibility.
and why it's called the trigger, the waterproof, because of how you connect it.
We have the two kinds of water samplers that we're using as vent fluid samplers. And this is, these are bottles that are on there that are intended for sampling from the chimneys, but we didn't get there today. And so what Z wants to do is simply to test it that the mechanism works and that they're successfully triggering it underwater with the ROV the way they think it works. It worked fine on deck. He just wants a single test to be sure everything's working okay.
Okay. No test is in vain.
Spent the last 8 days.
Supongo que va a ser como de 500 miliwatts. ¿Qué sigue?
¿Saben?
No tanto.
Creo que como uno. No, algo así.
700 miliwatts, yo creo. Ujú.
Are we there?
Yeah, they're trying to park.
Are you ready for info?
Is it on?
Is it on?
Is it on?
We're down, yeah.
Is it on?
Is it on?
The
Yes,
probe
it's
is on.
now. Yes.
The probe is on. Ok, estamos en la sexta estación y estamos esperando a que se retire un poco el sedimento del agua para ver bien en la cámara y poder insertar la sonda. Creemos que esta estación va a ser la última que hagamos en este transecto, ya que estamos cayendo por debajo del valor promedio de background. Y bueno, ahorita veremos en unos minutos más qué resultados tenemos. Entonces en esta estación estamos planeando, una vez terminada la medición, hacer tomar muestra de un núcleo de sedimento, un push core, y también probar una de las muestras recolectoras de agua, de las botellas recolectoras de agua. Okay, so now we are on top of station number 6. So waiting for the sediment to clear off, and yeah, just wait for his signal.
Okay, insert the probe, please.
Insert the probe, please. So we're inserting the probe as we speak, and I was just telling in Spanish a minute ago that we believe this is going to be our last station in this transect because we are approaching, or actually going below the heat flow value or the background value in this area.
Yeah,
Thank
that's
you.
good. Thanks.
And in this station we'll do a push core as well, and we're going to finish with a rehearsal of water sampling just to make sure that the bottles are functional.
From this view, you put everything on it. Yeah, it's exactly. If you look real, if you squint up real close, then you see it's trout. And that's if you left off. Are you okay?
So you want to play with the camera?
Sure. I always like to play with the camera.
Okay to move the camera? Yeah. Thank you.
Because of
700 milliwatts.
What's that?
700 milliwatts, we believe it's going to be this one.
0.7.
Yeah. So it's lining very well with the decay. The only anomalous value is the first one in terms of the decay.
Yeah, it's very.
It should have been higher, but we were in a different place, so there's no
Well,
reason to.
So if you think about the results that you had in the combination of the data and the model at Orca, what you showed was that there must be subsurface circulation that brings heat out, and so you get high conduction out here. This place doesn't have that.
Right.
There's no aquifer, and therefore the heat flow is very peaked. Then, that's kind of a lovely contrast between the two settings.
Yeah.
And faulting is nowhere near as evident here.
Yes.
And one of the things that I noticed with Steve talking yesterday is you go back and you look at the Pescadero Basin data in total, and it makes no sense. These vent fields are where they are. You know, we found them by accident. It's not as we were looking for. We wouldn't have looked. And the reason I'm thinking about that is because I want to go do all this stuff in the Farallon Basin. But what's the right thing to do?
Right.
Because where I want to look is where it ought to be, but that's not where we found it before.
Yeah, you're right.
Are we moving any more after this? No. After we retract from this and we turn it off, then we get push core, and then we trigger the so a single major, and then we're on about it.
Another isopod, Mr. Z?
I believe that is an isopod, yes.
Yeah.
And monopsidiae, if I remember correctly.
Dr. Ron was scolding me because he says that the biologists would be pretty offended because I call them bugs. Well, no pun intended, colleague biologist.
So, what is that thing again?
An isopod.
That's an isopod. That's
Yeah.
a sow bug in the bottom of the ocean. Oh.
It looks like a spider.
Monopsidiae, Monopsidiae is what
So,
Lisa told us.
okay. Did isopods evolve first in the ocean, or did they evolve subaerially and go into the ocean?
I'm going to say the ocean because almost everything did, except land plants.
Well, no.
So I think that's pretty safe.
Yeah.
If they're an ancient lineage, then they definitely did.
Well, okay.
But that's a geochemist speaking. Speaking out of turn, as usual.
That is a good dancer.
It's like really like dancing, like yeah. It's like literally moving through water when they say that, and
Yeah.
you know, yoga class like moves like you're moving through water. Then I'll remember this.
Yeah. Can you get it to focus on the critter?
Unfortunately, yeah. How do I take it out of autofocus? And then, where is my focus? It's the top one?
Ya a todos los disfruta, digo, al Néstor, al Marc, al Ismael estaba más cachos, todos estaban, pero seguro que estaba igualito. No, sí comen. Ahorita sí, le dejé una sopa y ahorita se iba a hacer una hamburguesa por ahí.
I don't seem to be focusing here. Oh, I'm on the wrong side. There we go.
You're gone. There you go.
Yeah.
Hey, where's he going?
It helps if you turn the one that says focus.
Hey, follow the critter. Send that to Kakani.
That's all you got.
Oops. Okay, can we go back to autofocus?
Autofocus.
Sorry. There we go.
minutes to get the confirmation on the thermal conductivity. It hasn't varied very much, but it's always good to finalize
Yeah.
the transect with the whole, but it's okay. So 7 more minutes. And then the push core is kind of fast.
Yeah, as long as they're still willing.
Not yet. Major? Not yet. Wouldn't do it without you, buddy.
And what's that, see?
That's an anemone. It's like the one that's open down to the left, but he's just starting to open up his tentacles. So it's an anemone that lives in the sediment, I believe. Actually, I think it is a different one,
What do
maybe.
you think is this?
Those are holothurian feces.
Oh, you're
And-
right. I'm
yeah.
sorry.
And-
he called it was feces, and it's like no.
Oh, and here's the culprit. Right. Oops.
No,
Let
this
me.
one.
Yeah.
Oh, oh my God.
There
Well,
he is.
So,
He did. He did indeed. Yes.
so the sea cucumbers,
Yes. Sea cucumbers. Yes. Holothurian sea cucumber.
Right.
Yeah. Who else is hiding from us?
Now, when you see that from this perspective, it looks most like a cockroach.
It does
Right.
look like a cockroach.
It's the same one that was in the.
What?
It's the same one that we saw. Looks
But
like.
now, yeah, it looks very different when it's
Sí.
walking.
So is the white shiny thing, is that a foraminifera? A benthic foraminifera? Does anyone know?
We're from different.
The one that the
Yeah, this one.
isopod, I think?
Well, Ron could tell.
Is heading towards, yeah.
So we're gonna be done like this, it's like 700, right? 3 more minutes. It's gonna be, but. Around that.
Where's the timer?
Well, it's just a number of measurements that it's taking. Yeah. So do you think we're gonna have to work with the same weather conditions for tomorrow? You told me not to look at the weather.
No, I was looking ahead. I think tomorrow is still okay. That was looking ahead of the weekend ahead of the possible storm. So I don't know if it's going to be this good tomorrow. But it's still going to be fine.
But today was just beautiful.
Yeah.
today was the day you tell your students, don't get used to this.
Okay, so we're probably a minute or two out here. I appreciate you keeping us going. Normally it's 6 o'clock. Are we okay to still do the push core and
Yes.
Okay, thank you.
Zero, we want to get the definite answer from, but we're okay. Is Zero in there?
I can write that down.
Zero, are you there? You're good with us doing the push core?
What?
You're good with us staying down, do the push core and major?
We're running a little late here.
For Ron, please.
Yeah, we could do a push core. Where are we gonna go to the major engine?
We're just gonna fire it to the bottom, just make sure it fires.
Yeah.
Yeah.
We definitely, we can even do it on the way down.
If you promise not to drop it.
Never mind.
I like the promises.
Don't create potential problems.
Okay, thank you.
Okay, probe out of the seabed, please.
Probe coming up.
Probe south.
Probe south. You can turn it up. Yeah.
Okay, close off. All right.
Probe south.
You may take a push core from anywhere within the vicinity.
Except through a holothurian.
All right. Well, okay, yeah, that would probably mess up the trace elements. Maybe not though. I mean, what's going to be different between the whole thing? It's only a question of the stickiness of the mud.
Yes, exactly. So, J-Red, is it possible to relabel the cores? We have them labeled 1, 2, 3, 4, 5. Can we go A, B, C, D, E? Because we want to refer to push core 1 as the first one taken, and if taken in 2, 3, then there's some confusion. So,
Yeah, however you want them labeled, so you want them push cores A, B, C, D?
yeah, just for, next time. Oh, those are already painted on the handles too.
Yeah. But I mean,
If it's
y'all are
not,
keeping the tubes, right?
we're going to actually extrude the cores and give the tubes back.
Oh, you are?
Yeah.
Okay.
So if it's not too much trouble, it takes out one level of confusion when we're going back through samples. If that's okay.
It's not a problem. Yeah, I have sheets for y'all, but since we weren't going to be doing all that other stuff, I didn't worry about printing it out. So, okay, sheets.
So, you finished narrating
Not so
push
much.
core, or
We're going to take the
There won't be a
I
lot
know
of
you
confusion
need
on the
to
push
let
core
the
side.
audience know what we're doing.
Oh, yeah.
Or I do
Yes,
that.
you may, please. I can only let part of the audience know. You can let all the audience know.
Ok, estamos de regreso. Ya se terminó la medición de la última estación de flujo de calor que vamos a hacer el día de hoy en este transecto. Y ahorita vamos a tomar una muestra de sedimento, un núcleo de sedimento. Entonces lo que están observando en la cámara es como el robot toma el tubo y lo va a insertar en el sedimento para que se comprima dentro del tubo y poderlo regresar a la superficie y poder estudiar algunas de las propiedades del sedimento y otras cosas, nada más. No encima del animal, por favor. Oh my gosh.
Yes, this is a sampling of it.
That was close.
Make sure we get some of the feces.
Please leave the animal unharmed. Okay, guys, so we finish up with the heat flow measurements on the transect today, and we are just taking a push core and unfortunately perturbing one of the residents on the area there, but he was completely unharmed, so you don't have to worry about him. And so, yeah, Dr. Ron, here's your push score. Push score number 1 for Dr. Ron. Te mando saludar.
Ay, yo también, muchos saludos. Muchos saludos.
Oh, insertion. Oh, insertion went all the way in there. It's full. So we, yeah. And then, let's put, Ron's name on there. Because we'll take it to him, and if he wants to search for it, it will show up with his name. Perfect. Yes.
Ok, de regreso a su lugar en la canasta para subir a la superficie que lo podamos recuperar aquí arriba a bordo del Falcor. So just back into place and just ready to come up to the surface so we can recover here at the Falcor deck. The cap is on and we're ready to move.
Didn't even move. What's that? Took it right next to all.
Oh, yeah, those things are tough to startle.
Yeah.
No, yeah,
Well,
he
they
didn't
have all
move,
this
huh?
pressure on them.
No.
It's just a normal day for them. They just eat mud.
With the amount of sediment, I think his day's been about a month long since he's moved last.
Yeah. Yeah, I think the only thing that would bother one of those would be lack of mud to eat.
Mm-hmm.
Lack of moss to eat. Okay.
Step in the ground.
That arm to pull the monkey system. Freeze it.
Oops. This was offended. That one.
Thanks, guys.
Three is fine. Just this one right here, the closest one, just not the gas tanks.
If it's all the same, could we do the orange one, number 2?
Number 2?
Yeah. I didn't like that bottle didn't go together as nicely, so I'd rather do that one if it's okay. If it's quicker to do the other one, that's fine.
Squash it.
You wanna grab the,
Yeah, I'm here to the end.
yeah, yeah,
Oh, I see. You want to do that?
yeah, take the,
Take us home.
take the, yeah, the throne and, he has really a soothing voice. You hear him narrating over there?
Yes, completely. He did like very well.
Yeah.
And I
Well,
never
our last activity here is to test fire one of the major samplers that we'll use on later dives to sample hydrothermal vent fluids. And so we just want to verify that all the mechanisms are working correctly and we understand everything.
No, yo no voy a estar ahorita, pero voy a ir a arreglar. Si no pasa nada, pues no me preparo.
So when we use this at a vent, we will be attempting to maneuver the nozzle at the end of the tube that's coming out of what is low in the screen to be located in the stream of hot water that we want to sample.
Make sure you don't trouble.
Which one's on?
Como el día que te quiero ir al baño, no me voy.
None ram?
So Z, what does he need to do? He needs to turn the T handle? Is that-
No, we have to see you just move the trigger there. The yellow pad goes in and out on a hydraulic ram. Once he picks it up, there's a trip trigger that you will see. They just got to push that ram into.
Oh,
that
I
trip
see.
trigger.
Okay, so on the manipulator, there's
the manipulator is
a
the
little
trigger.
hydraulic ram with a yellow piece coming out, and it lines up on the top of the sampler and it pushes that in, and it will push the trigger button. And to line up correctly, he needs to grasp onto that T handle. If he grasps on in the middle of the T handle, then everything should be lined up. That also lets you pick up the major, so that's how they
The
we'll
trigger's
pick
actually-
the whole thing via that T handle and maneuver it so that the nozzle is in the hot water stream or pool, as the case may be. It's one of these things that looks difficult, but it's actually much more difficult than it looks.
That wasn't fired, was it? Or was it? No. Okay.
Well, they have to fire it first. So might it be easier if we did a 180 on the hand so that that trigger wasn't pushing on the bottom when you're trying to grab?
What's that?
If we rotated the hand 180 so the trigger is above the bottle, because when you're trying to grab it, it was hitting the springs a little bit. Okay. Yeah, you, all right, I see. That doesn't work, yeah.
Yeah.
Yeah, this geometry is tight. We may have to start going down with two pairs instead of three.
Two's better, because I can space them way out.
I'm seeing that
I
this
think in the
is,
past we've only done 4, so when you get set up, I like,
yeah. I can see.
you always want more.
Of
What,
course.
6 is impossible? Can we do 8?
That's what I asked for the first time, actually. Yeah, there we go.
Okay, so now they grabbed it, and then they not trying to get any particular water, just any old water, and so they push the what do you call it?
The snorkel?
No,
The trigger.
the triggerer.
Yeah, we can't see the trigger right now.
Yeah.
It's behind the, we'll see it when they rotate.
Will we see the spring extend?
Yes.
Trying to get a better view, make sure that.
Right. So the reason we're maneuvering around here is so we can really see the thing work
Okay,
when
so
we test fire it.
with this geometry, it's going to be really hard to get into a map because the snorkel's going the wrong direction. You see what I mean? Because we're going to want that snorkel to go vertically into a map.
So you're going to want to fire it like this.
That's the best way to get into a venue is like that, but now we're on the other side of the trigger.
Spin.
Let's test it real quick.
Yeah. So let's zoom in
All
on
right, so-
the trigger.
So now we're zooming in on the trigger. The hydraulic ram will push that bolt in, and then we should see the spring extend into, well, out of the sampler.
Can someone do an event, Mark?
And there,
So,
yep, the spring is pushing out.
Wow.
yeah, this model, the springs are coming out slower than the others, but I want to take this one, yeah. But it's looking okay.
So it doesn't take much.
So we're gonna call this
We'll call it
major.
So we have to move the hand. We have to
More?
move the trigger.
Like that?
Yeah, not orange, the color orange.
Oh, major orange.
Yeah, that's right.
Major
And
orange.
then the notice for it.
Right.
I'm talking about
Right.
our RAM.
No.
No, it's vertical.
And then background, just in the notes, just the background.
Okay, so that's now sucked water into the sampler.
Yeah, the springs don't look fully extended to me.
It's
I'm
not.
not sure it's moving, but they don't look fully extended.
It's number what? Major number
You
what?
want them to try to,
Yeah, but it's
you want them
three
to try to
or
push the
one
ramp
or
further?
something. It needs to be anything.
I'm call it 2, but
Z,
yes.
he,
You want us to try to push the trigger a little bit more?
Yeah, you go ahead, that's fine. But I think it's all the way down,
I
right?
think so too.
If it's,
I think
once it's
the
open,
trigger
it's-
is a trigger.
yeah, I don't see it coming back.
well, that's as much as you're gonna get.
Yeah, and that's something we don't want to do. Okay, it's not coming out, so we're good. Down, go.
So full.
Yeah, that didn't extend all the way. I wasn't sure about that bottle when I put it in.
You have spares and the nozzles need to spend the nozzle a lot, maybe.
It
I
didn't
do
fire?
have some,
So that's what
What's that?
we could rebend,
Sorry, I'm asking.
but they're titanium.
So what happened? It didn't.
Okay.
It didn't
So they-
extend fully, so there's probably, there's water in there, but it's not a full volume.
I have the.
And so,
like
Right.
a stainless tube.
Yeah.
So Z's not happy with it.
Right.
But that's the one he felt was
The other option
dicey.
is too is if we go for.
The other thing that they're talking about is the shape of the nozzles, and the thing is that the choice of these nozzles is tied to wanting to be able to sample up into, you know, from below up into a volume under a flange or in a cave. And the pilots are questioning whether that's the best geometry or not.
Okay.
It sits like the other ones.
So it's to put inside of the cave and then.
Well, right, except we want to go up, right? Because the fluid is getting trapped under an overhang, and so we want to be able to put the nozzle up into the volume that's trapped. And normally the nozzles are turned the other way so that you can easily go down into, you have a vertical chimney and you're going down into it from the top. But that's not how these vent chimney structures form. These ones form with these flanges. So there may be, yeah, so there may be some changes in how Z puts those bottles together back together again tonight.
But I think it's mainly just the nozzle. These are different handles too than we're used to. They're
These are the same handles we were using on the majors last time. On the real problem handle was the gas pipes had different handles. And so we had to redo the trigger every time we used one bottle or the other. We couldn't use both ones, right? Because they had those long skinny handles.
and that's 25 piece. That's right.
Oh, that wasn't hard.
Okay, sorry, come on. Come on, bottom.
So John, do we need to do off-bottom events, or is that something that happens?
vehicle related will take care of it.
Okay.
Bridge, ROV.
ROV bridge.
Yeah, that's a soft bottom, trigger recovery.
We will do them on the same dies, but not at the same level.
Okay.
sign off.
Oh, yeah.
So yeah, so the same dives.
Same dives, yeah. Just not at the same time. Okay, well, we are stowing. We've come off bottom, and we're stowing that testing probe that we used at times to be sure we could put the heat flow probe in. And we're heading towards the surface, and it's going to take 2 hours or a little bit more to get all the way up to the surface, and then of course recovered and onto deck. The science party is really appreciative that the ROV pilots let us have some extra time today. We had to work through some issues with the hydraulics on the vehicle early on, and so
And tell them what we're going to do tomorrow.
so that's very much appreciated. So as we come off bottom, this is the effective end of Sebastian dive 463. Tomorrow we are going to come back to the same place, and we're going to continue doing the heat flow transects. We worked from the just south of the central edifice to about 350 meters or so to the southeast of the vent field. And tomorrow we'll work to the west, and then we will work a line that's 150 meters further north, another sub-bottom profile line collected with an AUV, and we'll collect all the way along that profile because we should have a full day tomorrow. I think that we will take time tomorrow at the end of the dive to do water sampling at a couple of the vent sites, probably including the cave that I talked about early in the dive, and probably including the Marker 5 site. So tomorrow it will largely be more of the same, but for a few hours longer. Back here at the JaichMaa hydrothermal vent field. We'll see you tomorrow.